Hello everyone, welcome back to my YouTube channel, General Technology Knowledge. Today I would like to show and share about how to install software Step7 MicroWin SMART version 2.5 on Windows 10 Pro x64 bits. That this software we can install on VMware player. Yes, I mean that in the previous video we already learned about how to install the VMware player for Windows 10 and already installed the software Step7 MicroWin version 4 page 9 on it already. So today we will install software Step7 MicroWin SMART version 2.5. It is the latest version to those Windows also. Okay, so let's go. So first we need to have the software Step7 MicroWin SMART version 2.5. Yes, and I will drop the software under my video on the description, so everyone can download this software to use to install for communication between our PC with the PLC S7-200 SMART. Okay, so let's go to installation. So in the setup application, so right click and then run as administrator and then click select the language that we want. There are three languages. The first one is Chinese, the second one is Chinese traditional, and the third one is English United States. For me right now I will choose the English United States. Yes, and then click OK to install. Okay, and then wait a moment for installation. Okay, the next step we should click next to accept the installation. Yeah, and then click I accept the term of the license agreement, security information. Yes, so tick here and then click next, and here is the default folder that we would like to install. So actually we can use the default folder. So drive C program 86 Siemens Step7 MicroWin SMART. Okay, so it is the default folder, so we don't touch anything and then click next. It will automatically install all components on this computer. Okay, so wait a moment for installation. It takes time around 3 or 5 minutes for the installation. Okay, it is very important for this software because it supports all versions of PLC S7-200 SMART, SR30, SR20, and also the expansion module. So it supports all the version of the PLC S7-200 SMART. Okay, and it's very easy. If we have this software, we can upload, download, and also create a new program for a library for our project also. Okay, so I will drop the link for download this software under my video to share to everyone that would like to use the software for configuration or create a new project for our plan. Okay, so wait for installation. After installation, I will test this software for everyone also for connect with the PLC S7-200 SMART about the communication between PPI cable or we can use the LAN cable communication between our PC to the PLC for all versions. Okay, so I will test for everyone. So right now we installation the software first. Yes. The last video I will simulation with the WinCC flexible also for this version. Yes. Sometimes I use version 2.4. Yes, but the version 2.5 it just released, so we can use the version 2.5 for instead or cover the version 2.4. Okay, so 2.5 is the bigger than 2.4, so it can cover the version 2.4. Yes. Okay, right now it installation the driver of this device configuration, so wait a little bit time for this installation. Okay, actually if our computer is fast, RAM around 8 GB or 4 GB or 16 GB, it will faster. But if our computer around 2 GB, it will slow a little bit for this installation software. But when we use it for download and upload or create the new program, it's not slow. Yes, we can use I mean that it can use the overall of the PLC communication. Yes, sometimes I use with Windows 7. Yes, this software is also support Windows 7 64-bit or 32-bit also. So if everyone have any Windows operating system, so everyone can download to use for communication for our PLC. Okay, for this window I install Windows 10. Yes, Windows 10 64-bit. Yes, and RAM around 4 GB. Okay, so right now it already installed the software component, so we can click finish to restart our computer. Okay, so I will click finish and it will restart, automatically restart the Windows. So wait a moment for restarting. Yes, actually after installation we must restart the window, otherwise some driver is pending for restart, so it will not work correctly if we don't restart it. So we must restart the computer, is better way for the equipment or component of the software is working smoothly. Okay, and after that I will test with the PLC S7-200 SMART for test to show to everyone. Okay, so right now we already restart the operating system for this window after we got installation. Okay, so let me open. Yes, open this shortcut, or we don't got the shortcut on the desktop, we can also go to start and then go to this shortcut of the same as in the desktop. Okay, so let me open from here. Yeah, just click and it will open the software. Yes, okay, so it is English version, so let's check the version about. Yes, here, so we will got version 2. Yes, we page 5. Yes, 2.5. Okay, so let's test with the PLC. So let's go. Okay, right now I already connected the LAN cable from my PC to the PLC S7-200 SMART CPU SR30. So let's open our software for test the connection or communication between our PC to PLC via upload and download. Okay. So before go to check the communication, here we must put the manual IP address of our PC. Okay. So right now the PLC IP address is 192.168.2.2. So we put IP address of PC as 192.168.2 dot something but not dot 2, right? So I will put dot 253. Yes. So let's go to put manual IP address. Go to Ethernet and chain adapter option here. Go to IP4. Yes, here double click. So I will set 192.168.2.253. Okay. 192.168.2.253. Okay. And for the subnet mask is the same, 255.255.255.0. Okay. Okay, so click OK. And then let's test the connection by use the command prompt cmd and then ping 192.168.2.2, right? Okay, it so like this, it means that we can communication between our PC to the PLC. Okay, so let's find the CPU by please find CPU S1, and then it will detect. Right now it detect one CPU, and here is the MAC address, here is the IP address and subnet mask of the PLC CPU. So click OK, and then we can upload by press button upload. And if we would like to save, we can click yes to save. Example, backup project PLC Smart, and then click upload. Okay, and then we can online also. Okay, here is the existing project that we already learned in the previous video. So we can online. So the software that we already installed is can use properly. Okay, so thank you very much for watching my video, and if everyone have any question, please kindly drop comment under my video. I will reply soon, and I would like to request all of you to like, share and subscribe my video also to get more notification and more new videos that I will create step by step. So in this time, I would like to say thank you very much again, and see you next videos. Bye bye. Hello everyone, welcome back to my YouTube channel, General Technology Knowledge. Today I would like to show and share about how to upload, download the program from PLC S7-200 SMART CPU SR30 with analog input EMAR02. In this section, I will use software Step7 MicroWin SMART version 2.5 and use the PPI cable that connect from PLC to our PC. Okay, and I will use 220 volt AC supply to the PLC, yes, and also connected the ground cable. Okay, so to upload and download the program, first we need to connect the PPI cable from the PLC to the PC port. Okay, it is the USB port, and here is the RS 485 port. Okay, so let's go to our software to upload and download or modify the program for test with the PPI cable. Okay, so let's go. Here is the PLC S7 here is the software S7-200 SMART version 2.5, and if we have the backup file, example I have the backup file here, so we can open and then download to the PLC directly. Okay, so let me test if I use the backup file like this. So first I will communication between PC and PLC. Yes, let's test here. So right now I'm not yet connect the PPI cable to the PC between PLC. So let me connect it. Okay, and I will choose the use visual machine because right now I use VMware player for test. So let me click OK and go to the communication again, and then choose the PC PPI cable. Yes, driver. Okay, wait a moment for communication between our PC to the PLC. Okay, so right now it found one CPU, address number 2, and baud rate 9.6 kilobyte per sec. Let's click OK, and then let me download the program to the PLC. So press this button to download, and I need to stop the CPU. Yes, if we download, we need to stop the CPU. Let me show the status of CPU right now. Okay, right now the CPU is running, and if I push the yes button, it will stop. Yes, and then download the program to the PLC, and after that the program is already downloaded to the PLC, and press yes again to run the CPU. Yes, and click close, and we can online to see the status by press this button. Yes, so now we can online. Okay, so right now I connected the PT100 from channel number 1 and number 2 of analog input. So channel number 1 is show around 28-27 degrees Celsius, and channel number 2 it show around 27 degrees Celsius. Okay, so if I hit the PT100, let's see, I hit channel number okay, I hit channel number 2. So let's see the number 2 is start increase. yes, and I will hit the channel number 1, 2. Let's see, channel number 2 is channel number 1 is start increase also. Okay, so if I would like to modify the program, yes, let me modify. Example, let me use comparator. Yes, example, this is a real, right? So let me less than real, or greater than real. Yes, here greater than or equal real. So MD 0. Example, greater than or equal 45.0. I would like to on the output. Example, Q 0.0. Yes. And for channel number 2 also, yes, for channel number 2. So I will use greater than or equal real. Yes, MD4. Greater than or equal 50.0. So I will let the output number 2, yes. So Q 0.1 is turned on. Okay, so we can save and then download to the program, to the PLC. Yes, okay, and then we can online to check. Okay, so right now the temperature channel number 1 around 38.9, channel number 2 around 32.9. So all output is turned off. Okay, so let me hit the temperature sensor to be greater than 45. Yes, and let's see the output status. So let me hit the channel number 1 first. Okay, now turn on because it greater than equal 45. I will hit channel number 2 also. Okay, it turned on also because it greater than 50 degrees Celsius. Okay, so let me show the status of output. Okay, let's see the output 0.0 and 0.1 is turned on right now because the temperature is over that we setting. Okay, so it will turn off if the temperature is decreased lower than 45 degrees Celsius and 50 degrees Celsius for channel number 2. Okay, and we also can upload the program. Let me show. I will close this one all. Yes, and then I will use the program. Yes, use the software Step7 MicroWin SMART version 2.5 to upload the program. Okay, so it is the blank document here. So first I will go to upload button. Yes, check the communication first. click Find CPU. Okay, and then click OK. And click the upload button to upload the program from the PLC to our PC. Okay, so let's click button upload, and if we would like to save, we can click save. Project 1 of PLC Smart. Okay, and click upload button again to upload the program from PLC to the PC. Okay, so wait a moment for uploading. Okay, so right now it was successfully for uploading, so we can online and check. Yes, so we can got all the program and all hardware configuration that we already configure here. So we can upload, download and modify program by using the PPI keyboard. Okay, so actually this PLC we can use LAN keyboard also. Yes, that I already show in the previous video. We use the LAN keyboard by set the IP address of computer to match with the PLC, so we can modify the program, upload, download and create a new program also. Okay, so I hope this video is useful for everyone, but if everyone have any question, please kindly drop comment under my video. I will reply soon, and I would like to request all of you to like, share and subscribe my channel also to get more notification and more new videos that I will create step by step. So in this time I would like to say thank you very much again, and see you next videos. Bye bye. Hello everyone, welcome back to my YouTube channel, General Technology Knowledge. Today I would like to show and share about how to communication and connect between PC to the PLC S7-200 SMART CPU SR30, and also connect with EMAR02. It is the PT100 input 2 channels, and also connect with the EMAR03. It is the input 2 channels and output 1 channel. Okay, so to communication between our computer with the PLC S7-200 SMART, this CPU, I will use LAN cable, and I will use the SIMATIC Step7 MicroWin SMART version 2.5 to communication. Okay, so let's go. Okay, so first I would like to open the Step7 MicroWin SMART that we already installed on our PC. So let's open. It is the version 2.5. Okay, and to communication between our PC with the PLC via LAN cable, or we can say Ethernet cable or RJ45. So let me connect the LAN cable to my PC and PLC. Yes, connect to PLC also. And then let's go to set the temporary IP of computer, and we also can test with the CPU IP address by go to the Ethernet LAN hardware cable. And here is the IP address of the PLC 192.168.2.2. Yes. And if we click OK, it should be has some error because we not yet set the temporary IP or set the manual IP address of our computer. Okay, so let's go to set the manual IP address of computer. Let's go to open the network, go to Ethernet, go to the Ethernet adapter, and go to property, go to IP4, yes, CTP IP address, and then we can set to the rank, yes, that I already mentioned in the slide. Here is the IP address of PLC 192.168.2.2, and here is the IP address of our computer. So 192.168.2.253. So we can put 192.168.2.253. And for subnet mask, we can put 255.255.255.0 because it's class C, and then we can click OK. OK again and close. And one more thing, we can check the firewall, yes, Windows firewall, by go to the control panel, go to Windows firewall here, and make sure we must put off for this Windows firewall, otherwise we cannot connect to the PLC. Okay, so we temporarily close it first. And then we can click Find CPU again to refresh. Okay, right now it detects the CPU again, and then click OK. Yes, so now we can click OK because we already put the manual IP address of our computer. So let me ping to test 192.168.2.2, right? Okay, it so like it means that we can communication between our PC with the PLC. Okay, so we can do by upload, download, or create a new program to the PLC. Okay, so first step, I would like to upload the program from the PLC. Please click on upload. Yes, and if everyone would like to save the file that already back up from the PLC, we can click yes and put the file name, example smart backup 1, and then we can click upload. Yes, so very fast. So after upload, we can online to check the condition of the logic. Yes, so right now it show around 26 degrees Celsius for channel number 1 of analog input, because right now I already connected the thermocouple and PT100 to the channel number 1 and number 2 of analog input. Okay, so it show the status. So here is the method how to upload the program from PLC S7-200 SMART CPU SR30 by using the LAN cable. So the next step I would like to show about how to create the new program and download to the PLC. Okay. So let's go together. So I will don't save this one first, or we can save, because otherwise we will lose something here if we not save. Yes, so we can keep if we click save. Okay, so to create the new program we must to know the hardware. Yes, so our hardware is CPU SR30, and here is the expansion module AR02. Yes, and this is a expansion module more AM03. Yes, so we need to put the expansion module to modules, right? Okay, so let's go to the software again to create the new project, and hardware configuration follow this step. Okay, so first I will open the Step7 MicroWin SMART again and go to communication again, don't forget, and select the correct adapter hardware of Ethernet that we already connect the LAN cable to this module. Okay, so right now it detects the CPU again, and I can click OK to confirm. And to create the hardware configuration, we must to know the model number or serial number of the module, right? So the first one is CPU SR30, the second one is EMAR02, and the third one is EMAM03. Okay, so first I select the CPU SR30, yes, here, and the SB I can use the battery, yes, and for CPU setting we can configure when start up. If we set like this, it means that when the power on, the CPU is stopped, but actually we want to run the CPU if power on. Yes, so we can set run and then go to the communication. Here is the IP address. Yeah, so we can also link with the PPI cable that I already show in the previous video. And for the input output we can use also, yeah, digital output. And for slot EM number 0, here we can set the EM AR02. Yes, so I will insert EM AR02 here. Yes, this one, 2AI RTD. Yes, so 2AI RTD. And for EM01 here, EMAM03, so we can select EMAM03. If we set config the hardware configuration wrong, we cannot download, or when we download we will got the error. Okay, so I will choose the correct expansion module, so EMAM03. And if you would like to configure, example for EM number 0 for RTD 2 channels, I can use the RTD2Y PT100, and scale is degree Celsius. For channel number 1 also choose 2Y resistance. Yes, and PT100 also. And for channel number 2, yes, we have totally 3 channels, right, for module number 2. And channel number 1, I will choose current for input. We have 0 to 20 milliamp. And for channel number 1, I also choose 0 to 20 milliamp. And for output, I will use 0 to 10 volt. Yes. And we can click OK after we hardware configuration. Okay. So here is the address that we will use. The first one is AIW16 to AIW18. It is the 2 channels of RTD input. And here is the 3 channel. Yes. So it will start from AIW32 and for output AQW32. Okay. So for the address, it will arrange automatically. We don't set it. Okay. So click OK. And then we need to show the actual of temperature to channel, right? Because right now I already connect the PT100 to channel number 1 and number 2 of analog input EM0. Okay. So to show the actual temperature, first let's go to convert from integer to real, right? And then divide by 10. So let's go to all the way on. So SM 0.0 and go to convert, right? So double integer, sorry, integer to double integer. So I can write integer to double integer here. And then I will create the temp file, right? Temp variables here. Example var1, and the data type is double integer, right? Because we need to put here. So double integer. So temp var1, and here is the address of analog input channel number 1, right? So channel number 1, it will start from AIW16. So AIW16. Yes. And then we need convert from double integer to real, right? So double integer to real and choose var1. And I will create the var2 variables. So var2, and the data type is real because we convert from double integer to real. Okay. So var2, and then I will divide this one by 10, right? It is the formula. So divide real, divide this one by 10.0, and then here is the output that we will got to show on the HMI or show on the some devices. Yeah. So I will put the memory. Example MD0, it is real. And for channel number 2, I will do the same. So I can copy here, and then copy here, and just change the variable and address of the output, right? So the first one I will change to var3. So I will create the variable var3. It is the double integer. So var3, and this one should be var3 also, and I will create one more variable called var4. It is the real, right? So real, so should be var4, and then copy and paste var4 divide by 10, and output should be MD4, right? Okay, so we can compile the program. Yes, no error occur. And for analog output, we can also write, right? So example, we can use the move. Yes. So this one should be analog out, right? AQW32, AQW32, yes. And this one we can put VW 100, example, yes. So we can test. So first we can save the program, yes. I can put the name, example, new project of PLC SMART, yes. And then we can communication again to confirm, find the CPU again, and it detect the CPU again, and click OK, and we can download, yes. And I will show right now the CPU is running, so let me show. Let's see, the CPU is running. So if I click download and click there, it will stop the CPU and then start download the program to the PLC, right? And after finish, I can click yes to run the CPU again, and the CPU is restart and running. Okay. So we can also online to check the status of the PLC. Yes. So right now, for channel number 0, it shows around 26.7 degrees Celsius. And channel number 2, I will change the input. So it should be AIW 18. And then let me download again. Run again. And then online again. So it show around 28, yes, 28 degrees Celsius. And for analog output, right now is 0, yes. So if we would like to test the analog output, we can also test. Okay, so let me show the volt, right? Because we put the volt for analog output here, yes, 0 to 10 volt. So I will connect the multimeter and let everyone know the volt. Actually we can set from here, right? So let me show. Okay, right now I already connected the multimeter to analog output of channel number 1 of module number 2, yes. So the rank of this module is The raw value is from 0 to 27,648, yeah, and from 0 to 10 volt DC, yes. So if we would like to set 5 volt DC, we can divide between 27,648 divided by 2 equal 13824, right? So if I set 13824, let's see the volt around 4.99. Let me show. Yes, let's see volt around 4.99. Yes. So if we would like to set the maximum, we can adjust. So 27,648, we will got 10 volt. Okay. So this is the analog output. Yes. So we can upload the program, or we can download the program or modify the program that we want by using the LAN cable and our software. Okay. So thank you very much for watching my video, and if everyone have any question, please kindly drop comment under my video. I will reply soon. Oh, I don't forget test this thermocouple, sorry, PT100 to see the signal. So let me test. So I will hit the PT100 for channel number 1 and number 2 to let everyone see. The first, I hit the channel number 2. Let's see the value is start change, yes, to 49, sorry, 71 degrees Celsius. And for channel number 2, sorry, number 1, I can also test by hit the PT100. Let's see, the value is start increase. Let me hit more. Okay, start increase 34 degrees Celsius. Yes. So it's very easy for communication between PLC S7-200 SMART via LAN cable to Step7 MicroWin SMART version 2.5. Okay. So I hope this video is very useful to everyone. Yes. And I would like to request all of you to like, share, and subscribe my video also to get more notification and more new videos that I will create step by step. So in this time, I would like to say thank you very much again, and see you next videos. Bye bye. Hello everyone, welcome back to my channel again, General Technology Knowledge. Today we will continue our lesson about PLC S7-200 SMART CPU SR30. Okay. So in the previous video, we already learned about how to set up and configure the analog input and output, and we already test with the standard sock and our program. Okay, so today I will explain more about how to setting the startup option of the CPU. Actually, most of PLC, when we power off and power on again, the CPU should be run. Yes, that make our process can running and production. Okay, but in this CPU, if we don't focus on the setting, when we power off, I mean that when we turn off the power 220 and turn on again, the CPU will stop. Yes, and we cannot run any machines. So we must configure to be start up to run the CPU. Okay, so to setting it, we will go to our software. Yes, let's go. So here is the software, Step7 MicroWin SMART version 2.4 that we already learned in the previous video. Yes, so let's go to open it. Yes, first we must check the communication. Yes, right now I already connected the LAN cable from the PLC to my PC. Okay, so let communication and then click here, but make sure you must manually the internet adapter of our PC to be the same rank of the IP address of the PLC if we want to use the LAN cable to connect between our computer and PLC. Mostly in this PLC we can use two options to connect between our PC to the PLC. First is the PPI cable. We can also use for this port, and the second we can connect from the LAN cable to the PLC. Okay, so let's check my PC. Yes, go here and then go to IP4. Yes, and check like this 192.168.2. something. Okay, okay, let's select here, and then the PC will find the PLC automatically. Please wait a moment. Okay, right now the PC found the PLC, one PLC CPU. Yes, that its IP is 192.168.2.2, and this is the MAC address of the PLC. We can compare in the nameplate of the PLC, or we can plus the line. Yes, plus the line like this. The PLC will show the blink on the board of PLC LED. Okay, so okay, click OK, and then the second step, let's go to the CPU. Yes, CPU. Right now we connected with the CPU model SR30. Yes, to set the startup option, let's go to startup. Yes, here is have three options: first stop, second start, run, and last. Yes. So if we choose the stop option, it means that when we power off and power on again, the CPU is stopped. Yes, the CPU is stopped. Okay, let's test. So I click OK. Yes, and then if I write sample program like okay, all the way on, and then output example CPU output Q 0.0. Okay, and then download to the PLC. Yes, and start the CPU. Yes, right now the CPU is running. Okay, I will show you the CPU is running. Yes, right now the CPU is running. Yes, if I power off, okay, I power off and re-power on again. Yes, you see, the CPU is stopped. It not run. It means that the setting stop. Yes, okay. So right now the CPU is stopped. Yes, it's not working. Yes, the output is not right also. You see. Yes. So when we online, we go to run again. Okay. So actually we no need a programmer to be online when we power off and power on again in the local side. Okay. So we can go to the setting again. Yes, go here and then go to the startup, and then we select run. Yes, and select run and download again to the CPU. Yes, yes, and run the CPU, and I will show you again. Yes. So right now the CPU is running. Yes. So if I power off again, power off, and then I will power on again. Yes. Yes. You see the CPU is running. Yes. So the setting is currently that we must set the startup to run. Okay. So let's go to other option. Yes. The last option. Yeah. We can choose the last. Last, it means that when the last time CPU is stopped, when we power on again, the CPU is stopped again. Okay. So when the last time is CPU run, example, then we power off and power on again, the CPU is run again because it remember the last time of the CPU status. Okay. So we can select it to last and then go to download again. Yes. Okay. Run CPU again. So the last time is CPU is running. You see the CPU is green right now running. If I power off and power on again, yes, the CPU is run again because we set the setting is last. Okay. I will stop the CPU and let you see the status. Yes. Yes, okay, right now the CPU is stopped. Yes. And I will power off. Yes. And then power on again. Yes. The CPU is still stopped because it remember the last data of the CPU. Okay. So this is a concept what I want to share to everyone about the CPU setting of the PLC S7-200 SMART model SR30. Okay. So actually maybe we can set like this. Yes. Set to run. Actually we most PLC we set to run. Yes. When the power off and on again, the PLC should be run to support the production for product any tool. Okay. So thank you very much for watching my video. And if everyone have any question, please comment under my video. I will reply soon. Okay. And don't forget support me by click like, share and subscribe my video to get more notification and more new video that I will create step by step. Okay. So thank you very much again and see you next video. Bye bye. Hello everyone, welcome back to my channel again, General Technology Knowledge. Today we will continue our lesson about PLC Step7 MicroWin SMART CPU SR30. Okay. In the previous video, we already learned about the setting of CPU that if we would like to turn off the power and return on again, we can setting to CPU stop or CPU automatically start. Okay, and we already tested in the previous video. Okay, so in the next here I would like to show and share about multi-connection from the PLC S7-200 SMART to touch panel, smart line, and we also connect from software programming. Yes, software programming from here to the Ethernet switch. Okay, so in the case we can upload download to the touch panel. Yes, and download the program to the PLC via LAN cable from the PC by using this Ethernet switch. Yes, this is a LAN port that we connected. One port is connect from the PLC to the switch. Yeah, and other LAN port connected from the HMI to Ethernet switch also, and one more port for connect from our PC to the Ethernet switch. So in the case we can ping from our computer to the HMI and also ping from the our computer to the PLC also. Okay, so I will test for let everyone know, and we will create the sample program to download to PLC and download to the HMI, yes, via LAN cable from our PC. Okay, so let's go to our program. Yes, so first I will ping to the HMI. Yes, so ping 192.168.2.3, right? It is the HMI. And one more, ping 192.168.2.2, right? It is the PLC. Right now I can connect it from my PC to HMI and also PLC. Okay, so we can program and download to the PLC and HMI. Okay, so here is the previous video that we learned about the analog. So let online. Yes, here is the online connection that we can connect it to the PLC. Okay, so here we can create one more program for download also. Yeah, example, I have stop button example 0.0. Yes, NO contact start 0.1, and example Q 0.1, sorry, Q 0.0, and then hold the signal also. Yes, and we can use arrow key and control and arrow key up. Yes, so right now let's save our project. Yes, it is the example that I want to show. We can connect the multi-connect from our PC to the HMI and the PLC via Ethernet cable by through the switch. Okay, so let's download our program to the PLC. Yes, I stop, done, and then I will online again. Yeah, so right now we will go to create the project in WinCC Flexible Smart. Yes, here is the project. We can also close and open again. Yeah, close and open again. Yeah, here is the existing project that I already created in the previous video. Yes, so we can use this project to download to the HMI. Yes, here is the analog input. Yes, analog input here. Yes, that we can show at the HMI also for the raw value. Yes, and here is the button stop, button start, and output. So here we can also property. Yes, this one I already created the text for those button. Yes, here is the AIW setting. Yes, and this is a motor, this is a start. Yes, this is stop, So here, so let's go to download our project to the HMI. But before download, I would like to explain a little bit for this analog. In here, in the previous video, we can select right from like this. Sorry for the screen. Yes, here is the raw value. Yes, if we select from 0 to 20 milliamp, so the raw value will start from 0 to 27,629. Okay, so in here we can also show at the HMI with the percentage, right? Percentage, I will copy, yes, and then paste. This is the percentage, yeah. So here is the setting, yes, for show at the HMI for percentage. So let's go to this tag and then go to here and then go here, and here we can start from 0, yeah. So here is the PLC value. If PLC show 0, the HMI show 0% also, and here is the maximum of the raw value. Normally 27629, right? 27629. It is the maximum value of analog input. So if we setting like this, in the HMI will show 0 to 100%, and here is the 0 milliamp, and here is the 20 milliamp. Okay, so click OK and save our project, and let download to our touch screen. Yes, but before download to our touchscreen, I will reset the power of touchscreen first. And then power on again. Yes. And go to the touchscreen. And then please transfer. Yes. And then go to download. Yes, download. Yes, right now we already download to the touchscreen. See the value. Yes, this is the raw value of AIW16. I can adjust to yes, from 0 to 20 milliamp. yes, to 20 milliamp, it will show 100%, right? Yes, 100%, yes. And also I can press start, yeah, see the CPU, start, stop, yes, start, stop, okay. So we can connect the multi-connection from the PLC S7-200 SMART via LAN cable by using the Ethernet switch. Okay. Yes. So thank you very much for watching my video, and please comment under my video if everyone have any question, and don't forget like, share and subscribe my channel also to get more notification and more new video that I will create soon. Okay, so thank you very much again, and see you next videos. Bye bye. Hello everyone, welcome back to my channel again, General Technology Knowledge. Today I would like to show and share about how to link display TD400C version 2 keypad to the PLC Step7 MicroWin SMART CPU SR30 by using the configuration software Step7 MicroWin SMART version 2.5 for setup or without the TD400C version 2. Okay. In this video, I will show how to press F1 for increase the value, press F2 for decrease the value, and press F3 for reset the value. The same as previous video that I will show already about how to use the S7-200 link with the keypad, but in this video I just use S7-200 SMART. Okay, so let's go. So first let's open Step7 MicroWin SMART software, and then go to wizard. Yes, go here and then click text display. Yes, okay, and then I will choose the TD. Yes, TD4 because we use the TD400C version 2. Yes, and then press next, and here TD4. Yeah, press next again, and this is a version. Right now I use version 2. Yes, the same as the slide that I already showed. Yes, so I choose version 2. So very important for TD type and version of TD. Okay, so here is the name of the language. So first is Chinese, and I can select English also, and I will change to Latin one, and then click next, and click next again, and we will choose the as fast as possible, yes, not delay. For when we freeze or message, no need to delay, just fast as possible. Okay, so we select as fast as possible. So click next, and then here it's similar to be the step 7, yes. So here I can use the momentary for F1, momentary contact for F2, and momentary contact for F3, yes. And then click next. And here is the name of the screen. We can specify example ABC, yes. Click next. ABC D, yes. Example. Then click next again. And here is the screen of TD that we want to show. Example, I use this row for show the value of VW10, yes, example. So here I can choose the address of PLC that we want to use. Example VW10, yes, so I can use 10 and use unsigned, yes. And then click next. And if we would like to create the sum screen, we can use here, yes. I can use full, and then click next and next again, and click generate. Okay. So right now we already wizard the configuration, yeah, of TD of keypad, yes. So we need to call it to the program block, yes. So I will choose NO and then choose always on, and then use the call, yes, TD control, yeah, to here, and then I use the key, right, F1 for increase. So we can select here, scroll here to find the F1, TD F1, yeah. Okay, and then I will use the positive A contact also, yeah, for increase step by step. And then we can use the increase word, increment word. So VW10 that we already configure on the TD, yes. So VW10, and one more for F2 for decrease, right? So TD4 F2, yes. And then we will use the function decrease, DEC, increase word, yes. I will copy a little bit, yeah, here. DEC word, decreasement word. So VW10 also. And I need to use the positive A contact also, yes. Okay. So we can use the reset also for F3. So we can scroll to find the F3 for reset the value of VW10. Yeah, TD F3 here. And then no need to use the positive A, right? Because we just reset. And we can use move word. yes, 0 to VW10, yes, and we can download. Right now I use LAN cable for download the program to the PLC, yes, so I can compile, yes, compile the PLC, yes, no error occurs, so we can download, yeah, click download and then find the CPU. It will find automatically because we already connect the LAN cable from the PC to the PLC, yes, so fine. Okay, right now it found one CPU that have address 192.168.2.2, yes, and this is the MAC address, and we can flash, yeah. If we flash, let's see to the CPU, it will blink the LEDs, and then we can click OK to download, yes, stop the CPU and then run again. It finished, and then we can online to see. Okay, let me show about the keypad, yes. So right now it shows 0 for VW10, so I can increase by press F1, yes, increase, and also decrease, yeah, step by step, yeah. Let's see the PLC, it show the condition also, yes, and we can press F3 for clear, yes, like this, increase again, yes, and reset, yeah, reset to 0, yes. So it's very easy to use the keypad with the PLC S7-200 SMART for increase the value, or we can control another program that we want, yes, because right now we can communication between the display or keypad to the PLC S7-200 SMART, okay. And this is just example to everyone about how to link or how to visit the display to the PLC, yeah. So thank you very much for watching my video, and if everyone have any question, please kindly drop comment under my video. I will reply soon. And I would like to sorry if I have some mistake in this video also, and I would like to request all of you to like, share and subscribe my channel also to get more notification and more new videos that I will create step by step. So in this time I would like to say thank you very much again, and see you next videos. Bye bye. Hello everyone, welcome back to my channel again. Yes, in the previous video we already learned about how to upload the program from PLC S7-200 SMART model CPU SR30. Yes, today I have topic more about how to read the data from encoder by using PLC S7 SMART 200 SMART. Yes, so first go to software Step7 MicroWin SMART. Yes, I would like to introduce some part that we use for read the data from encoder. Yes. So first, this is a PLC. Yes. This is a PLC S7-200 SMART CPU SR30. Yes. And this is a connector PPI cable. Yes. That I already connected from PLC to computer. Okay. And this is a encoder. Yes. Encoder. We can increase and decrease value that we want. Okay. And one more, this is a button reset that if we want to reset the value, we can push the button, the value of encoder will reset to 0. Okay, so I will show you in the software. So let's start. First, communication between our computer to PLC S7-200. Yes. So click communication to confirm that we can connect it or not. Now it finding the CPU. Yes. Right now it found one CPU that connected already. So the status is show connected with PPI cable address number 2 and transmission rate is 9.6 kilobyte per second. So let OK. To read the data from encoder, first go to tool, yeah, and then high speed counter. Go to high speed counter. Yes. First I choose the high speed counter number 0. Yes, number 0. Totally it have 6. Yeah, it has 6 high speed counter. But right now I use high speed counter number 0 first. Okay. So click next. Yeah. HIS number 0. And next again. Yeah. This is we must select the mode for read data from encoder that we want. For example, mode number 0. Yeah. Mode number 0. Single phase up down counter with internal direction control. No reset input. Okay. So we can read the manual operation from this mode. And HAL in the HAL file also have yeah. So right now I choose mode number 4. Yeah. Single phase up and down counter with external direction control. Yeah. If we want to up and down, we just adjust the encoder. Use reset input. Yeah. And also has reset input. If we want to reset to 0, we can use the input for reset the value. Yes, it is the meaning of use reset input. Right now, click next. Yes. So it is the default. example, I choose the VD0 for PV, VD0. Okay. So click next. This one no need to tick any checkbox. Click next, next again, and click next. Yeah, this is very important for manual operation, right? You see HSC0 clock connect to I0.0 that I already show you in the actual PLC, and HSC0 also direction I0.1, and reset button will connect to I0.4. Okay, so we use 3 inputs. One for clock. Input number 2 is direction. It means that we can increase and decrease the value. And input number 4 is the reset. So click next again, and click generate for finish our configuration. Okay. So right now we already configure the high speed counter. So the block will here, and we can open for check the block. You see, yes, automatic generate, and also automatic write the address for us. So next step, go to here, main program, and go to file, and then click here. So first we must enable the first scan for on to initial the block, right? So I click first scan, and then initial this block. Also one more for initial the high speed counter 0 block. So click here, and then go to first scan. First scan, right? And O, and then first scan. Yes. And initial this block. Okay. So to read data from encoder, we must use the move double word block. Yes, move double word block, and then AC0 for high speed counter 0, and this one we can use VD0 that we already set up on the configuration, and this one should be always on for connected to energize this block, energize power for this block. Okay, so right now we already writing the program, so let's save the program and choose this one, and you can say read data from encoder using PLC S7-200 SMART CPU SR30. Okay, so let's download our program to PLC. Click download, and then click download again, and stop the CPU. Yes, the program already download from our computer to PLC, so we can online and test it. So right now you see the value of encoder is still 0. Yes. So if I would like to adjust the value, I might turn off the power first because we download the configuration. So I turn off power for PLC. Yes. And after 3 seconds, I turn on again. Okay. Turn on power again. And we online for check. Yeah. Okay. So right now the value still 0. So I will adjust, increase the the encoder to see the value. You see the value is changed from 0 to 10, 12, 13. Yeah, you see. If we want to decrease the value, we just adjust decrease, right? See, the value is decreased. And if we want to reset the value, we just press the button reset. You see, the value come to 0 if we reset, and we can adjust again. The value is changed again. Okay. So this is a instruction about how to read data from encoder using PLC S7-200 SMART model and CPU SR30, and using PVI cable for communication. Okay, so thank you very much for watching my video, and we will see you next video. And if you like my channel, please like, comment and share my video also, and don't forget subscribe my channel also. So thank you very much again, and see you next video. Bye bye. Hello everyone, welcome back to my channel again, General Technology Knowledge. Today we will study about the PLC S7-200 SMART that we will use and test the analog input for those modules. Okay, so here is the PLC SIMATIC S7-200 SMART, and here is the expansion module that we can call AM03. In this module, it has two analog input and one analog output. Okay, and here is the CPU that we connected from the CPU to the EM module via connector here. Yes, and here is the digital input and output, yes, of this module. Okay, so today we will focus to analog in and analog output of this module. Okay, and here is the drawing that I already draw to show to everyone about the PLC S7-200 SMART EM. Yes, and here is the power supply 220 volt AC that supplied to this terminal 12, 13 and 14 is the ground. Yes, and when we supply the 220 volt to the CPU, the CPU will provide the output 24 voltage DC, and we can use this power supply to supply to the EM, because EM it will supply 24 voltage DC, otherwise this module not working. Okay, and for this terminal for spare, and this one spare also we not use, but for terminal 4 and for terminal 5 we use the analog input number 1 that it will start from AIW16, and for terminal 6 and terminal 7 it use for the analog input number 2 that it start from AIW18. Okay, this is a register for this module. Okay, and one more for analog output module. Yes, analog output channel, it will start from AQW16, and this is the raw data and the standard signal of output. Actually we can select milliamp current, and this is the voltage, and here is the raw data. Yes, and for analog input it also start from 0 to 20 milliamp current input. Yes, and we can input the voltage also start from 0 to 10 volt DC. Okay, and the raw data is the same. I will test and show to everyone about this raw data. Okay, so this is a drawing of this module. Normally when we buy the PLC we get only this one CPU. Yes, SR30, and this is an extension module that we can add to use with the VSD or use with the thermocouple or something other instrument that we can use. Okay, so to configure this module, EM module, let's go to our software Step7 MicroWin SMART. Okay, so let's go. So here is the software Step7 MicroWin SMART version 2.4 that we already installed in the PC. Okay, so let's open it. Okay, first go to the config the CPU. Yes, for our CPU is SR30, right, and AM 0C. So go to this and let's select SR30. Yes, this one, and this one is the communication port that we can use the LAN port or Ethernet port, or we can use the RS485 port that we call the PPI port. Yes, so in this video I will use the IP address, yeah, internet card. Okay, so let's go to config the EM. Before config the EM, we can use the battery. Yes, this one is the battery. Normally inside the CPU it has provide the battery. Okay, so select the battery, and for EM we can select to AM03, right, to match with our modules. Okay, and the address is automatically provide us. It will start from AIW16 to AIW18, right, because it two channels. And the output, it will start from AQW16. Okay, only one output. And I will explain more about this function. For module parameter, which alarm should be enabled for this module? This is a question that the programmer add this question for us. If we tick like this, it means that when we not provide the 24 voltage to this card, it means that yes, it means that we don't supply 24 voltage to this card. It means that it will alarm. Okay, when we tick, and when we not tick, and then download the program to the PLC, it not show alarm when the power cut off. Okay, so normally I recommend to use the use power. Okay, to let our user know, yes, about the problem. Example, power cable cut, yes, or something wrong. Okay, and then let's go to the analog input. Yeah, for channel 0 we can select volt or milliamp. Okay, volt or current. For voltage, it can use 2.5 volt, 5 volt, or 10 volt. Yes, but in this step I will choose current. It will start from 0 to 20 milliamp. Okay, and channel 2 also. For analog output channel, we can select current or volt also, and I will select the current, and it will start from 0 to 20 milliamp also. Okay, so let's save our project and then go to communication to check the communication between our PC to the PLC. Okay, so in this section I choose the LAN cable, so I will check my computer first to make sure that the IP address is manually. Yes, so IP4. Yes, right now the IP address of my PC is manually and 192.168.2.10. Okay, for this one we can choose any number, example dot 100 or dot 153. Yeah, like this also. Yes, and I will choose this one. Yes, for communication between my PC to the PLC. Okay, so right now the PLC is connected with our computer. Yes, and this is the MAC address. Normally we can plug this line to check our CPU. Let me test for us. So when I click like this, yeah, You see the address, sorry, the lighting is blink. It means that this is a CPU that we connect from the PC. Okay, and one more for this one. This is IP address. So actually we can ping. Yes. We can ping 192.168.2.2, right? Because it is the IP address of PLC. Okay. So right now we can ping. It means that we can connect it from the PC to the PLC. Okay. Let's click OK. So to check the standard signal of analog input to our program, let's go to add the allow on, yes, and move word, right? We call it integer, so we move word, yes, and it is the address of analog input, so AIW16, and then this one the memory, internal memory that we can use, example VW0, yes, and one more channel, so we can move also move word, yes, move word, and it will AIW18, right, and this one VW4 example, yes. Why we need to put like this? Because here is the reference address, and here is the address that it will start, yes. So right now we already add the program for test. So let's go to download to the PLC, yes. Okay, done. Then go to online and then start the PLC, yes. So right now you see the value of the analog input is connected to the channel number 1, yes. So right now let me adjust the milliamp. Okay, here is the meter, yes, multimeter, and I already selected to milliamp, yes, selected to milliamp, and actually we can adjust from 0 to 20 milliamp, yes, and here is the terminal, yes, terminal that we already connect to the channel number 1. Here is the minus, and here is the plus, yes, and I will adjust to 0, okay, 0 milliamp, and the display will show 300 something, right, because it is not 0, okay, and if we adjust to the 20 milliamp, yes, yes, the value of the analog input will go to the maximum, okay, 20 milliamp, okay, yes, like this, okay, 20 milliamp, yes, 20 milliamp, So it will show the same the drawing that I already show you here, around 27,600 something. Okay, and here is the channel number 1, and if we want to connect to channel number 2, I let connect it. Okay. Okay, right now I already connected the standard source to the terminal number 2. Yeah, here is the channel number 2. Yes, this one is plus, this one is minus. Yes, and I selected to 20 milliamp also. Okay. So the raw value the same. Yes, the same value. It is the standard. Yes. Okay, so thanks you very much for watching my video, and if everyone have any question, please comment under my video. I will reply soon about how to add the extension module of the PLC S7-200 SMART or some setting. Please comment under my video, and please support me by like my video, share and subscribe my channel also to get more notification and more new video that I will create soon. Okay, so in the next video we will learn about the analog output for this channel. Okay, so thank you very much again, and see you next videos. Bye bye. Hello everyone, welcome back to my channel again, General Technology Knowledge. Today we will continue our lesson about the PLC S7-200 SMART, about the analog output setting. Okay. In the previous video, we already learned about how to configure the EM module, and we already tested the analog input from the standard source to the program. Okay, and here is the program that we generate for testing the analog input modules. Okay, so today we will continue our lesson about analog output. Yeah, it means that this channel output. Yes, for this channel we use terminal number 6 and number 7. Yes, number 6 and number 7. That number 6 is minus and number 7 is plus. Okay. So we can test with our program by create the move value to AQW setting. Okay, so let's go to offline first. Then I will move this one. Yes, I will move this one to the analog output. So we can copy, yes, or we can drag and drop the new mover. Yes, this one we can choose the VW4. Yes, because the rank is the same, so we can choose this output to move this input to the analog output. So AXUW16. Okay. So right now we can download and test. Yes. Okay. So let's check to our terminal. Okay, right now I already connected the terminal of the analog output from this channel. Yes, and when I adjust the milliamp to be less than 20, yes, you see the analog output will generate less also, because right now I connected from this standard source to the input 2, yes, input 2 for this one, yes, this terminal and this channel, and then it will generate the output, move this data to this one to measure with the multimeter. Okay, so I will adjust to 0 for test. Yes. Okay, 0. It have milliamp a little bit. It's not 0. 0 point something. So when adjust to 16 example or 8 milliamp, yes, it will generate 8 milliamp also to the our analog output module. Okay, 20, go to 20 milliamp. Okay, it will generate 20 milliamp to the output also. Okay, see the terminal. Yes. So it is to how to test the analog output module of PLC S7-200 SMART. Yes. For S7-200, we no need to add something module. It generates automatically. But for this S7-200 SMART, we must configure the module. Otherwise, it not working. Okay. So thanks you very much for watching my video, and please comment under my video. If everyone have any question, I will reply soon. Okay, and don't forget like, subscribe, and share my video also to get more notification and more video that I will create step by step. Okay. So in this time, I would like to say thank you very much again, and see you next videos. Bye bye. Hello everyone, welcome back to my YouTube channel, General Technology Knowledge. Today I would like to show and share about how to use the PLC S7-200 SMART CPU SR30 with the extension module, analog input and output EM-AM03. Okay, and in this section I will show and share about how to create the scaling analog input. It means that we can do 4 to 20 milliamp or 0 to 20 milliamp to with the analog input to generate the scale. Okay, and here is the sample just highlight, and I will create step by step to show and share to everyone about this block. Okay, so before go to create the scaling of analog input, I would like to explain a little bit about how to wiring the connection of this PLC. Okay, so right now I already connected the cable of milliamp from this standard source to the analog input module. Yes, and I will explain about the detail of this module. Okay, so let's go. Okay, so here is the drawing of the analog input module EMAM03 that connected to the SIMATIC S7-200 SMART CPU SR30. Okay, so for terminal of CPU 12, 13 and 14 is 220 AC, and terminal number 9 and number 10 is 24 voltage generated from the CPU. Yes, so we can use this one 24 voltage to supply to analog input and output module. Okay, so we can connect L plus with the L plus, M with M. Yes, for terminal number 1 and number 2 of EM03. Yes, and for terminal number 4 is analog input channel number 1 minus that connect with terminal number 5. Yes, it means that number 5 is minus and terminal number 4 is plus. Okay, and for terminal number 6 and number 7 is channel number 2 of analog input, because in this module it has 2 channels of analog input and 1 channel of analog output. For analog output, we can use terminal number 6 and number 7. That number 6 is minus and number 7 is plus. Okay, and for analog input of this module, we can select 0 to 20 milliamp or 0 to 10 volt DC. Yes, and the raw data is from 0 to 22,600 and around 48. The standard is 48 something. Okay, and for analog output is the same. Yes, 0 to 20 milliamp, 0 to 10 volt. It's up to everyone that select in the software configuration. Okay, and I will show about how to configure the current or volt in the next step. Okay, so that's all for drawing, wiring, how to connect this module between CPU and the expansion module EMAM03. Okay, so the next step we will create the scaling block and create the HMI screen for simulation. Example 0 to 100% or 0 to another rank that we want. Okay, so if we adjust the milliamp, it will decrease or increase from 0 to 20 milliamp or 0 to 10 volt. Okay, so let's go to our software to create the scale. Yeah, I will explain step by step and show how to do it. Okay, so let's go. So first we need to have the software Step7 MicroWin SMART. Yes, so let's open. Right now I use version 2.5. Yes, and before go to create the scaling block, I would like to make the communication first between our PC to the PLC. Okay, so first go to CPU. Yeah, so we need to set up the CPU first. Yes, so go to the CPU type. Yes, actually we can select the CPU type. Example, my CPU type is SR30, so I will select SR30. And for SM we can use battery for this one. And for the EM we can select another EM that we have. So right now I already connect the EM AM03. It means that has two channels of AI and one channel for AQ. Okay, so we can select it, and the address is start from AIW16 for analog input and also AQW16 for analog output. Okay, and we need to configure the input setting. Yes, for analog, the first we can select volt. So if we select the type of volt of input, so we can use like this. Yes, and right now I will use current, so I will select current. Yes, and for current it has only one option that we can use. Right now I will use 0 to 20 milliamp. Yes, DC. And for channel number 1 we can also select 0 to 20 milliamp. And for analog output we can also select volt or milliamp also. Yes, so right now I will use milliamp. Yes, use current. So this is how to implement to select the input type. Example, your instrument devices use volt, so we can use volt. If use current, we can use current. Okay, and we need to set the CPU startup option. Yes, so normally we can select run. Yes, so that's all, because we already configuration of the software. Okay, and the next step we must make the communication testing with our PC to the PLC. Okay, so first we need connect the LAN cable or PPI cable from our PC to the PLC slot. Okay, and then go to the communication. Yes, we can click here or we can click here. So if we click here, we click only one, but when we use with this one, we can double click. Yes, the same. And here is the communication interface that we will use. So right now I use LAN cable, and here is the Ethernet driver of my PC, so I can select. So wait a moment, it will detect automatically. So right now we can show the one CPU that automatically detect. So here is the MAC address, here is the IP address, here is the subnet MAC, here is the gateway of this CPU. Okay, and we can set our computer IP address to the same as this range. So let me show. So let's go to right click here and then go to Open Network and Sharing Center and go to the Internet access. Yes, local area connection, and then go to Property and go to the IP4. Yes, and set here example 192.168.2.253. Yes, and this is the subnet MAC, and we can click OK. After that we can click OK. Yes, so we can ping 192.168.2.2. Yes, so it's so like this. It means that we can communication between our computer with the PLC. Okay, good. So in the next step we need to create the scaling, yes, of analog input. So before go to create the scaling, I would like to explain about the formula how to create this scale. Okay, so let's go to my Excel file. Yes, so here is the Excel file that I already prepared for easy to explain to everyone. So the first is the parameter and the second is the data type. Okay, so normally we have 3 for input and output. We have 1 parameter. Yes, and this is a formula. So output equal input multiplied by high scale minus low scale divided by the maximum value raw data of 20 milliamp or 10 volt here. So around 27,648 and minus low scale. Okay, and here is the data that I already simulation, so I can simulation for everyone. Example, I set the scale low scale 0 to 100%. Yes, and here is the real. Yes, and for the raw value is integer. So if the integer is marked, it means that 20 milliamp. So the output show around 100%. Okay, so if this one divide by 2, it will show around 60%. Sorry, 50%. Yes, so we must create the scaling, follow this formula. Okay, so let's go. So first we need to create the input and output parameter in the block. So let's go. So to create the analog input block, first we can go here. Yes, and we can insert the subroutine or interrupt, or we can use this block. Yes, can rename this block. Example, analog input scaling. Yes, AI scale. Okay, and we can click OK, and we go to the var table. Yeah, here. So we need to create follow our Excel that I already explained here. So first we need to create the input parameter. So let's go to input. Yes, and we can insert row for input because we use totally 3 input. So here we can use input is the data type integer, right? So we can select integer from here, and we can comment something, example raw data, and the second is high scale, right? So high scale, I can say sorry, I can type a scale in with that high scale. Okay, and the data type is real, so we can use real. Okay, and the next step is low scale, so L scale. The data type is real also. Yes, so we select real, and here is the command. We can command by low scale. Okay, so input we already created for parameters. So the next step, we must create the output, right, to show the actual value, example 100%, 50%, or 20% something. So let's go to out, and we can write out, and it is the real also. So this is the output. Okay, and then we need to convert from integer to double integer, and from double integer to real also. Okay, to calculation. So first I will use always on. Yes, normally we use always on, otherwise if we use the block without this always on, it will error. Okay, I will show. So first we need to use the subtract, right? So go to sub integer, right, or sub real. Okay, we can use sub real. Okay, sub real here. But before go to sub real for this block, we must convert first. So I will convert from double integer, sorry, from integer to double integer, right? So in to the in. Yes, but don't forget put the always on. So SM0.0, and we will convert from input, right? So in to the double integer, and then double integer to real, right? So di to real here, double integer to real. So first we need to create the temporary variables. Yeah, here. So let's go to temp, and we can insert. Yes, can insert the temp. Okay, so number one, I will use temp1, and the data type is in double integer, right? because here convert from input to double integer. So I can use din, sorry, din, yes, dint here. So we can use temp1, yes, and we can copy and then paste here, and we need convert to real, right? So here I can declare more variables, temp, so temp2 example, and the data type is real, right? So real, okay, so this one temp2. So right now we already convert from input to real, yeah, from integer to real. So the next step we can use this temp, yeah, with our formula. So temp2 sub between, right, high scale and low scale, right? Okay, let me show the formula. Here high scale minus low scale, then multiply by input, right? So multiply by input, so we can use mul real, okay, mul real. So temp2 multiply by high scale minus low scale, right? So we will declare this one more for temporary variable. Example temp3, and the data type is real, right? So this one should be temp3, and copy this one to multiply with the input that we already converted from integer to real, and then we need to create one more for temporary variables. So temp4, and it is the real also, right? Because we will use here. So real. So this one temp4, okay. After that we will divide by maximum of raw value, right? So maximum of raw value we can use divide real, okay, divide real. So we will divide this one, yes, by maximum of raw value 20 milliamp or 10 volt, right? So 27,648.0, yes, because it is the real, so we need to put 0.0, and we will got one more for temp. So temp5, it is the real also, okay. So temp5, and the last one we need to add, right? We need to add with the low scale. Example we need to add real, okay. So we will add temp5 and low scale, yes, and then the result is out, right? Because it is the output, yes, here. So we need to compile to see the error or not, yes, okay, no error occur. It means that we can use this block. So I will explain again to make sure. So output equal high scale minus low scale multiplied by input divided by maximum of the raw value and all this one plus by low scale. Okay, so this is a converter, yeah, from integer to real, and then let's go take this one to multiply by high scale minus low scale, and then divide by maximum, and then uh, plus by low scale. Okay, so that's correct. So we can comment this one: analog input scaling of PLC S7-200 SMART. Yes. Okay, good. So we can save our project. Yes. Scaling. Okay. And to use this block, let's go to main program. Yeah, to call this block use. So first we need to put the always on. So SM 0.0, and then go to call subroutine. Yeah, here we will found the block that we already created. So we can drag and drop this block to use by use the mouse. Yes. So here is the input. So input, it will start from here AIW16, right? So AIW16 for input channel number 1, and here is the scaling example 100.0 and start from 0.0, and this is a memory, another memory address that we will use, link to another block or link to another HMI. So example, I use MD0. Yes, because it is the real. Yes. After that, we can compile again to see. Okay, no error, and then we can save, and then we can download to our PLC. Okay, and during download, it will stop the CPU a moment. Yes. So I will show. Let's see, the CPU is running right now. So we will download, stop the CPU, and then download finish, and then we restart the CPU again. Okay. And we can go online by PC. Yeah. So we can see the raw, yes, value and the actual of the scaling for output that we already created and use it. So if I adjust the milliamp, yes, decrease milliamp, let's see the raw value and the output of scale is decreased also. Okay, example, I will adjust to 0 milliamp. Yes, 0 milliamp. Okay, around here, because we cannot adjust to 0, it error a little bit. Yeah, so around here the raw value, and if I adjust milliamp to 12 milliamp example, so it will show around 50. Yeah, because our scaling is 100. Okay, so it show around 50 something. Yes, so our scaling is correct. Yes, and we need to show this value to the HMI also. So let me show. Yeah. So first go to Windows Flexible 2008. Right now I use the page file. Yes, and create the new project. Yes, empty project, and go to panel. Yes, and I will use TP177B 6-inch color. Yes, wait a moment for opening the project. Okay, so first we need to create the connection. Okay, double click the connection, example HMI 1. Okay, and we will choose the SIMATIC S7-200 right here, and we can comment something, example connect to PLC S7-200 SMART CPU SR30. Okay, and here we can select the Ethernet because we just simulation between our PC with the PLC, right? Okay, so we can connect Ethernet, and here is the IP address of computer that we already put here. Yes, so 192.168.2.253, 192.168.2.253, and here is the IP address of PLC, right? So this PLC is 192.168.2.2, right? So 192.168.2.2. Okay, and then go to create the text, right? So here is the text that we will show, example MD0. Yes, so double click the text, and then go to take one, example take one. The connection and the data type is real, right? So start from MD0. Yes, example scaling or temperature sensor, example temperature sensor 1, range from 0 to 100 degrees Celsius. Okay, and we can use the IO file. Yes, here to show the data, and then go to output because we use output, and we can browse the text that we already created. Yes, here, and we can adjust the font a little bit. Yeah, example tacoma boolean, sorry, bold 16, and we can adjust the center and middle. Yes, and here is the value that we would like to show, example 99.9. Yes, and I will modify the color of the background to here. Yes, and then we can use the color of text like this, and we can use the bar, yes, here. Actually we can use hopper or something, so we can use the bar for show the scale when we adjust the milliamp, yes. Okay, and the unit example degree Celsius, so I can use like this, and one more like this. And we can decrease the font a little bit to be 16, yes, and change the color to be example white. Okay, white color. Okay, so we can see the bar, or we can see the raw value also, yes. Okay, like this. I will adjust a little bit. Okay, and then we need to create the text, right? So here we can go to general and choose the text that we want. So the text here, yes, and here also choose the text, yes. And for this color we can use another color that we want, example this color or this color, yes. And then we can simulation, yes, click simulation to see the data that link from the PLC, yes. Okay, so right now it show around 60 degrees Celsius. So if I adjust the milliamp, yes, let me show. If I adjust the milliamp to more than 12 milliamp, let's see the screen is vary also, yes. Okay, 20 milliamp something, okay. So we can use it like this, okay. So if everyone would like to use the hopper, it means that like this. So I can show a little bit, go to graph and go to the symbol, yes, example hopper. Let's go to 10, yes. Okay, another hopper that we can use here, yeah, example use this hopper. So we can use this bar, yes, send to front. Okay, like this. Okay, example your level of liquid or something, so we can use this format, yeah. Example I will change this one to matter or medkit, Yes. Okay, like this. And the liquid, we can use another color that we want, example this color. And then we can simulation. Yes. Okay, so we will got around 83.2 met cube. Yes. Okay, so this is just example to everyone about how to create the scale. Yes, of this block to use with the analog input of PLC S7-200 SMART. Okay, so thank you very much for watching my video, and if everyone have any question, please kindly drop comment under my video. I will reply soon. And I would like to say I'm sorry if I have mistake in this video also. And I would like to request all of you to like, share, and subscribe my video also to get more notification and more new videos that I will create step by step. So in this time, I would like to say thank you very much again, and see you next videos. Bye bye. Hello everyone, welcome back to my YouTube channel, General Technology Knowledge. Today I would like to show and share about how to create the analog output scaling of PLC S7-200 SMART CPU SR30 and connect with the analog module, expansion module EMAM03. For expansion this module, there are two channels of analog input here, and there are one channel for analog output. Okay, so here are example of how to wiring the connection from analog output series with the multimeter and connect to the control valve. Yes, so right now I'm connect to the input of control valve, and control valve will feedback the signal to the analog input. Okay, so here is an example and the concept for easy to understand, and I will provide the power 220 volt AC from this plug to the circuit breaker. Okay, and I will use the software SIMATIC MicroWin SMART version 2.5 and connect with the LAN cable from the PC to the PLC. Okay, so this is the concept. So to create the scaling and testing, I would like to let everyone go to create the subroutine and the program. Okay, so let's go. So I will use the existing project that we already learned in the previous video. Yes, so let's open. Okay, in the previous video we already learned about how to create the scale for analog input. Yes, here. And today we will create the analog output scaling. Okay, go to create the scaling. I would like to show the Excel file that I already created the formula, yeah, for create. So here example low scale 0 to 100%, and here is the output that will generate to analog, yes. And here is the input value. Example, we would like to put the, okay, I will show the value of this one. This is the raw data of the analog output that will generate from the percentage that we set. Example, the control valve set 100%, so the raw value that generate to analog output around 2765. Okay, and if we set point 50%, around 30,824. Okay, follow our formula. Yes, so we need to understand about the formula. So output equal the maximum of the raw value of analog output from 0 to 22,648 multiplied by input minus low scale, and divide by output, sorry, high scale minus low scale. Okay, so it will generate this formula. And if we set point 100%, it will maximum, yes. Okay, so the parameter that we will create is 4 parameter. The first one is input, the second one is high scale, the third one is low scale, and the fourth is output. Okay, output. So let's go to create the subroutine. Yes, to create the subroutine, let right click here and then insert the subroutine. Okay, and we will go to property to change the name of subroutine. Example a out, it means that analog output, yes, and click OK. So it will change the name to analog output. And let's see here, here is the subroutine, yes. Now we just created one more for analog output. Okay, so first we need to create the parameter. The first one is input, so input, it is the real, yes. So here we can comment input value, and the second is high scale, right? The raw data, yes, so the data type is real also, and we can comment high scale, yes. After that, the low scale, so low scale, it is the real also, so we can comment low scale. And one more for output, right? So output, it is the integer, right? So integer, so this is the output, analog output. Okay, so right now we already created the formula, sorry, created the parameter for input, high scale, low scale, and output. So we must follow our formula. So output equal, yes. So first we need to create the input minus low scale. Okay, so we can comment here, input, or we can copy this formula. Yes, we can comment here. So the first one, sub real, right? So sub real, sub between input and low scale, right? So input, low scale, and I will create the temp example TE1. Yes, temp 1. It is the real, right? Because output of this one, so the data type is real. So here I can use TE1. Okay. And the next step, we will create the high scale minus low scale, right? So I can use sub real again. So sub between high scale, so high scale minus low scale. Yes, and here I create the TE2, and the data type is real also. Yes, so this one TE2. Yes, and don't forget put the always on. Yes, so SM 0.0 for always on, otherwise it will error when we compile. Okay, so we will take this one, the maximum value of analog output, multiplied by this box. Okay, so I can use mul real. Yes, multiply real. Yes, so multiply between input, so maximum to 27,648.0. Yes, because it is the real, multiplied by input minus low scale, right? So this one, and we'll generate one more for TE3, and the data type is real also. Yes, so TE3, and we need to divide, right? Sorry, this one divide first. Divide between this one and this one. So I will insert here one more box. So divide real here. Divide between this one and this one. Then I will create one more for temp3, right? So TE3. Then I will copy TE3 to here, and then we'll generate the TE4. It is the real also. Yes, so TE4. Okay, so let me explain again. So here we need to divide between input minus low scale and high scale minus low scale, then multiply by the maximum of raw value of analog input. Okay, so this one divide this one, and then this is the result, and we will take the result of the divide real to multiply by maximum of raw value, and then we will got the TE4. Okay, And for this one is the real, right? But the output is integer. Okay, so we need to convert from the real to integer, right? So I will use the function truncate. Yes, this one. So first convert this one to the double integer, right? So I will create TE file. It is the double integer DINT. Yes, this one. So this one TE file, right? Okay, and then I will convert from double integer to integer. So double integer to integer, right? So di to I. Okay, and then I will use te file, and this is the output, right? So output, yes, and then I will compile. Yeah, click here. So error 0. Yes. Okay, so we can use this subordinate by go to call. Yes. So I will copy this one to here, and then drag and drop the unlock output scaling to here. Yes. So we will got like this. So for output we can use AQW 16, right? Let's go to check on the hardware configuration. Yeah, here. So the analog output will start from AQW 16. Yes, and it is the 0 to 20 milliamp. Okay, and for the scaling we can start from high scale 100% example, and low scale 0 to 0.0, and here is the input value, example MD4. Yes, so we can compile. Yes, okay, no error occur here, and then we can download to the PLC. But before download to the PLC, let's connect the LAN cable to the PC and to the port of PLC. Okay, and then make sure the computer is set the manual IP address 192.168.2. something. Yes, here is example. I set 192.168.2.253, and for subnet mask we can use the follow this one. Okay, and we can check the connection to the PLC. Example ping 192.168.2.2. Yeah, because the IP address of PLC is 192.168.2.2. Okay, so it's so like this. It means that we can communication between our PC to the PLC. Okay, so we can download by click this button, or we click the communication. Yeah, here, and then find the CPU. Okay, right now it found one CPU that has IP address 192.168.2.2, and here is the MAC address of this module, and click OK, and then click the button download. Yes, so if we download it will stop the CPU. Yes, so let me show. Okay, right now the CPU is running. So if I click download, yes, click yes to stop the CPU, yes. So right now the CPU is stopped, and then click yes again to run the CPU, yes, because we already downloaded. Okay. So we can online, yes. So right now MD4 input is 100%. So the milliamp show 20 milliamp right now. Okay, it show 20 milliamp. So if I adjust to 50% example, it will show around 10 milliamp. Yes, because the range is 0 to 20 milliamp. Okay, if I put 0, it will show 0 milliamp. Okay. So we will create the HMI for simulation. Yes. So let's go to the existing project. Yes. So actually we can set point from the HMI. Yeah. Example, set to open the actuator or control valve from 0 to 100%. So we can do also. Yes. So let me open the existing project. Okay, this is an existing project. So we can adjust something here. Okay, it is the tank. So it is analog input. Yes. So I will create one more text for set point and feedback of the control valve, right? Because we connect to the control valve here. Yes. So we need to actually we can use 0 to 20 milliamp, or we can scaling a little bit for 4 to 20 milliamp. Okay. So I need to create the take two for MD4. Yes, this one for set point, or we can write set point. So set point to control the control valve. Okay. And one more for feedback. Feedback from control valve. So example MDH. Okay. And then I will copy this one. Yes. So this one should be text file. So control valve. setting, control valve setting, and then go to property and then change this one to text. I will increase a little bit for size 16, and then choose this one to center and middle, yes, and then go to the color. Maybe I use the yellow color, yes. Decrease a little bit to 14, yes. So this one is SV, right? Set point value. I will use the white color and increase a little bit for size, yes, like this. And this is the feedback, yes, feedback from the control valve. So this one is process variable, right? So PV. Okay, and the unit is percent, right? Okay, and this 1% also. Okay, and for this one SV, right? So we need to use the input because we need to tie the sum value to control valve and choose the take set point, yes, and here is the feedback, right? So I will revise the program. Example, I will use the one more input for feedback, right? So I will use the scale, yes. So this one should be AIW 18, right? Input 1, and scale from 0 to 100%. So 100% for high scale, 0% for low scale, and this is a MDH, yes, because we already created here, yes, feedback. So this one should be output and then choose the feedback, yes. Okay, right, and then save the project, and then we can download this logic to the PLC again, yes. CPU will stop and start again, and then online. Okay, so right now I will revise the connection from standard soft from channel number 1 to channel number 2 of analog input. Okay. Okay, so if we simulation, okay, simulation. Oh, this one not see, right? So I will adjust this one a little bit more. For existing data, right, of level. Okay, like this. Okay, and then save again, and then simulation again. Okay, so right now if I set point to 50%, yes. Okay, let's see the milliamp show around 9.99, around 10 milliamp, yes. Okay, and if I adjust the input, yes, let's see here the feedback is show around 48, 50, yes. And if I if I set point to example 75%, yes. Okay, let's see the milliamp around 15, yes. And this is the feedback from the control valve, yes. Actually we can adjust, yeah. But for the real practice, we take the signal from the output of the control valve, right? Okay. So if I adjust to 100% or 90%, yeah. Let's see, the milliamp is show also, yes. And this is a feedback from the control valve, yeah. So it will increase also. Okay. And if I adjust to 100%, yes, it will show around 20 milliamp, yes. And then the feedback will go to 100% also, yes, from the control valve. Okay. So this is just example for how to create the analog output scaling to control the electrical devices or some device that can use from 0 to 20 milliamp or 4 to 20 milliamp. Okay, so thank you very much for watching my video, and if everyone have any question, please kindly drop comment under my video. I will reply soon. And I would like to request all of you to like, share, and subscribe my video also to get more notification and more new videos that I will create step by step. So in this time, I would like to say thank you very much again, and see you next videos. Bye bye. Hello everyone, welcome back to my channel again, General Technology Knowledge. Today I'm very happy to show and share about how to create PID control by using Step7 MicroWin SMART version 2.5 and WinCC Flexible 2008 for create the HMI. Yes, and I will connect to the PLC SIMATIC S7-200 SMART CPU SR20 and also connect to the expansion module for analog input and analog output also. Okay, so here is the sample program, yes, that we will create after I explain. Yes, and here is the graphics for tuning the PID control after we created the block. Okay, and here is the HMI that we will create some screen like set point, feedback, manual set point, output, yeah, and the mode control. Normally PID it has two modes, mode auto control and manual control. Okay, if we press the manual control, we can manual by this one. Example, would like to turn on the VSD, yes, with how many percent? Example, 25% or 30%. Yeah, we can use the manual mode. And if we would like to use the auto mode, we can press this button and then it will automatic calculation and follow with the feedback control. Okay, so let's go to our software to create the program. Yes, so first open the software SIMATIC Step7 MicroWin SMART version 2.5. To create the PID control, first go to Tool tab and then go to the PID. Yes, and then choose the loop 0. Actually we can choose another loop control. Yes, totally 8 loops. Yes, but in this video I will choose the loop 0 for control. Okay, so let's click next. This is the name of loop 0. Next again, this is again sample time, integral time, derivative times. Okay, so we can use default first, and after we create the block, we can tuning with this value also. Okay, click next, and then I will choose the unipolar. Yes, unipolar, many mode. Yes, and here is the scaling for PV. Yes, process variable. This is a low rank. Yes, 0, and this is a high rank, 27,648, and this is a loop set point. If process variable 0, it will loop set point 0, and this is 100%. Okay, then click next, and I will choose the analog for type of the loop. Yes, actually it has digital also, but in this lesson I will choose the loop for analog, and this is the analog scale. Yes, it will start from 0 to 27,648. Okay, this is the raw value of analog input and output of PLC S7-200 SMART. Okay, so click next, and then if everyone would like to have the alarm output, example low alarm, high alarm, yes, it will generate for us. Okay, let me show you. Right now I am not ticks. Yeah, and then click next first, and this is a manual control enable. If we not ticks like this, it means that we cannot use the manual mode. Yes, okay, I will go first and then I will show you again. Okay, next, and this is the address. Yeah, next, and then generate. Okay, so right now I will drag and drop the PID block. Yes, from the subroutine to the main program. Yes, you see right now it has only PB and set point. Yes, and have only output. Okay, because we don't enable the manual control and the alarm output. Okay, so I will show you again. So let's go to PID again and next again. Yes, so if we would like to have the alarm output, we can tick like this. Yes, it will generate for us. Also the manual control, if we tick like this, yes, it will generate for us also. Okay, so let me drag and drop the block PID from subroutine to main program again. Yes, you see here is the manual set point and auto or manual mode, and this alarm. Yes, after we tick the option. Okay, so we will use this block for tuning the PID control. Yes, okay, I will choose always on. Yes, normally we choose always on, and here is the block of PID, so we can freeze F1 if we want to read something. Yes, we can read also about the manual operation of this block. Okay, actually the PBI, it means that the analog output from the instrument, it means that feedback control. So we take the feedback from the instrument to connect here, and then here is the set point value. Here is the mode, auto or manual. If it turn on, it will auto mode. If this turn off, it will manual control. Okay, and this is the output. We can connect it to the VSD or the actuator or some electrical device that use the analog. Yes, for control our process or control the loop. Yes, and this is the high alarm and this is the low alarm. Yes, so first go to the hardware configuration. So right now I will add one more card for analog input and output. Right now we use AM03 that has two analog input channel and one channel of analog output. Okay, and actually this is the battery of the PLC. And we will connect, yes, and configure the analog input. Right now I will choose current first, that start from 0 to 20 milliamp, channel 2 also. And for analog output I will choose current also, that it will start from 0 to 20 milliamp also. Okay, and the address for analog input, it will start from AIW16, yes, and analog output AQW16. Okay, so let's click OK. And actually this is analog input, right? So AIW16, yes, and here is the set point value. I will use some memory for real value, example VD0 or VD10, yes, like this. And this is the manual mode, yes, or auto mode. So I will choose the boolean, example M0.2, yes, and this is a manual set point. If we would like to use the manual mode, example VD20, yes, or I can use some memory, because VD20 we already use in the PID block. Okay, so example I will choose the VD 40, yes, and this one is the output, right? Actually we use analog output, right? So AQW16, yes, and this one for high alarm, yes, I will use the boolean, example Q0.0, and this is the low alarm Q0.1, yes. And here is the mode control, yes. So we need to create some interlock for mode control. Example, freeze one button, it will turn off this one, and one more button is the turn on this one. So we need to create the interlock, yes. So example, I freeze M0.0 and M0.1, yes, and see it will turn on M0.2, yes. Okay, so we can go to PLC and then compile, yes. Okay, no error occur. Then we can download this project to the PLC also. Okay, so let me save the project first, yes. S7-200 SMART PID control. Okay, so let's check communication between our computer and the PLC. Yes, click communication and find CPU. So wait a moment, it will take time. Yes, right now it found one CPU that has address 192.168.2.1. okay, and this is the MAC address. Yes, subnet MAC and gateway also. So click OK, and then go to download button, and then download to the PLC. Yes, stop and turn on again, and go online and check. Okay, you see right now is the mode control mode manual, right? And this is a num, so we need to convert this one to the real first. Yes, so we will convert. So I will outline and then go to the, I can convert from double integer to real. Yes, so convert from double integer to real. So this one VD 40, right? And this one VD 100. Yes, sorry, double integer to real. VD 40, VD 100. Yes, and one more for convert also from VD 50, yes, to VD 108 example. Yes, and then let download again, and online check again. Okay, VD5 example VD 60. Yes, then download again, online check. Yes, so right now it's not error, right? So we can test. Example, I will turn off this button and then turn on this button. Yes, right now it auto mode, right? And set point 3. Yes, and the output is still 0. Okay, so we will adjust the set point. Yes, by using the HMI. So right now we will go to the WinCC flexible for create the set point. Yes, set point value. So go to the WinCC flexible and create the empty project. Yes, and I will choose the touch panel. Yes, yes, my touch panel is TP170B. Yes, 170B. And color also. This is the my touch panel. Okay, okay, so first let go to the connection for create the communication between HMI and PLC. Okay, so example HMI 1. and we will connect to the S7-200 SMART, and this is the connection. So I will choose the standard and the baud rate normally use 9600 and here is the PLC address, and this is the port port number. Comment you can comment S7-200 SMART CPU SR20 and then create the text. So first manual mode, right? We will choose boolean because it is the boolean, right? Here is the manual control. So M0.1 is the manual mode, and the second is the auto mode. M0.0, and one more for manual, right? Manual set point and set point value. So VD4 is the set point value. Sorry, VD40. So we will create the manual set point, right? This is a set point, so I will choose set point value. I will choose the double integer, and VD40, right? And one more for manual set point, VD60, so manual set point, manual set point, double integer also, and VD 60, and go to the screen and then create the button for manual mode and auto mode, right? Example manual mode, and I will copy one more button for auto mode. Like this. For manual mode, I will config. So go to event and then click, when click, and then invert bit there. We will choose invert bit and bit manual, right? And one more for reset the auto mode, right? So we need to use the reset bits and the auto mode. Okay, so when freeze this button, it will turn on the manual mode and reset the auto mode, right? This one also. So click invert bit and then choose the auto mode, and also reset when reset the bit manual mode, right? When click the auto mode, should be turn off the manual mode. Okay, so reset manual mode. Okay, and we will choose the label. Yes, go to the text label, and this one for set point, right? I will change the font. Yes, property text, I will choose center and then middle. Yes, I will choose 16 14 for font. Yes, and I will copy one more for manual set point. Yes, so long. Yes, we can write like this, manual SP. Yes, I mean that manual set point, and I will choose the IO file. Yes, and this is a set point value, right? So go to input. Yeah, set point is the input, and this is the format. Yes, this one is double integer, so we can choose the 999. Yes, example 0 to 100%, so we can choose 999, and this is a tag, right? So set point value, yes, like this, and go to property and then text. I will increase the font and then choose the center and the top. Yes, the module. Yes, the middle, and then I will choose the general. Yes, property, I will choose the black color, and for the text I will choose the green. Yes, green color, and here is the sub outside. Yeah, I will choose color, white color, and we can copy. Yes, only change this one to menu set point. Yes, that's all. So we will change the color also when the auto mode or manual mode until, right? So go to manual mode and then go to color animation and then choose the manual mode, right? So manual mode bit, yeah, the background, yeah, 1 and 0. When it 1 will be take to the green color. Yes, this one also. So take auto mode, right? Bit 0 like this, and 1 it should be green. Yes, okay, so let's save our project. Yes, go to the desktop and then go to the PID control, right? I will choose the new folder, S7-200 PID screen. Okay, or PID HMI, like this, and this one is the PID HMI. Yes, So right now I will download the screen to the HMI. Yes. So right now I will connect the USB from HMI to my PC. Yes. And then let's check the manage to see the COM port first. Go to device manager. Yes. And let's see the COM. Yes. Let's see the COM port. Right now I will choose the COM trees for connect to download the HMI. Yes. Okay, so right now let's click download. And I will choose the COM tree, right? And serial and then transfer. Yes. Yeah, it will confirm to download. Okay, right now we already download. We can online the PLC. Yes. And then let me set the manual mode or auto mode, right? So right now it's the auto mode, right? So I can set point, example 60 degree. Yes, something. You see the output is generate the output for control the some electrical device, right? Let's go to see the trend by go to the tool and then go to the PID control panel and choose the loop 0, right? So here it will show the trend. Yes. Example, I will increase or decrease the set point. Example, decrease to 50%, yeah, or 50 degree. Yes. The output will generate also. Okay. You see here is the PV, the red color, and the blue color is the output, and the green color is the set point value. Yeah. Right now the set point and the PV nearly the same, right? This is the PV. Example, I adjust the analog input, yeah, to be more than this one. You see the output start decrease, right? The output start decrease from 50% to 40%. Yes. So if I decrease the input, yes, I decrease the input, you see the output will increase. Yes, by calculation. Yes, from this one. So this is a concept how to create the PID control for PLC S7-200 SMART by using the loop 0, yeah, for control. And the next video I will create the HMI for show the overview. Example, the manual set point, the output, yes, the PV in the HMI. Okay. So for this video, I would like to say thank you very much for watching of everyone, and I would like to request all of you to like, share and subscribe my video also to get more notification and more new video. that I will create step by step. Okay, and if everyone have any question, please drop comment under my video. Yes, I will reply soon. For this time, I would like to say thank you very much again and see you next videos. Bye bye. Hello everyone, welcome back to my channel again, General Technology Knowledge. Today we will continue to set up the screen for HMI by using WinCC Flexible 2008 V4.5 and some block that related to the PLC S7-200 SMART for PID control. Okay, so we will create both more PLC and more screens for HMI also. For PLC, I will use LAN cable that create some block on the Step7 MicroWin SMART version 2.5 and then download by using the LAN cable. And one more for HMI screen, I will use WinCC Flexible 2008 and then download to the HMI by using the RS232 convert to USB and then connect to the PC. Okay, so let's go to our software. Yes, I will use the existing project that we already learned in the previous video. Yes, so I will revise some blocks that related to this block and write the command also, too easy for understand. Okay, so first I will delete this block first by writing some command. Yes, so I will insert some network. Yes, example here, network. First we need to show the PV, yes, to the HMI, right? So I need to write some command like show PV to HMI. Yes, so here is the PV, so data type is word, so I will move word. Yes, let's go to move and then move word, and normally we use the NO and then always on. Yes, and then copy this one and paste this one, and here is the memory word that we will assign. Yes, example I will use VW0. Yes, for show at the HMI, and one more for this is a mode selection, right? So we will write some command like mode selection, M0.2 on equal on. Yes, it means that auto mode. One more, M0.2 equal on, sorry, equal off. It means that manual mode. Okay, so we need to write some command for easy to read the program and easy to understand for check. Okay, So in this network, we will choose the auto mode, right? So auto mode, yes. If auto mode, the M0.2 is turned on, right? So I need to insert, yes, and O, and then copy this one, yeah, Control C, Control V. And if M0.2 on, we will have the auto memory from this one, right? Yes, to control the electrical device like drive or VSD or some electrical device that we want to control, right? So from here is word memory, right? So I will move word. Yes, I will move word from other frame memory to the analog output, right? Yes. So here I will instead some memory, yes. Example VW 1000, yes. And this one is the VW 1000, right? Or we can use VW example 200, yes. So I will copy this one to paste here, right? To move, to show at the HMI. And then we will move, yes, word one more to other memory to show at the HMI also, okay. So example VW 210, yes. So this is for auto mode, and one more for manual mode. Manual mode, right? So when manual mode, the M2, sorry, 0.2 will turn off, right? So I will use NC, yes, nominal close, and then copy this one, paste to this one, yeah. And then I will move word, yes, one more, move word from the manual set point, right? We need to create the manual set point one more, right? So I need to create the insert the network, and then manual set point value, yes. Manual set point value from the HMI, right? So I need to convert, yes, double integer to real, right? Because here we need real, yes, real memory to connect here. Then I will use VD 500 example, yes. This is everyone can use any memory that we want, yes. And this output VD 520, yes, example. This is just example, yes. And I will convert this one to integer. Yes, so this one copy paste example VW100. Yes, so when manual set point, yeah, this one we need to always on also, otherwise we cannot compile, right? Yes, so when we set point from the HMI to this one, and then this one will connect to here. Yes, and then we'll connect to the analog output, right? So AQ W16. Yes, and one more for show at HMI. Yes, right? So show at HMI. Yes, we use this memory. Yes, like this. And the last one for set point, right? Set point value for auto mode, we need to set point to here, right? Actually, when we use auto mode, we need to set point. Example 10 bar or 10 kilopascal or 10 degrees C. So we need to insert the set point for auto mode, right? So this one, set point value from HMI for auto mode. Okay, so I need convert from double integer to real, right? Sorry, convert from double integer to real. Yes, and this one should be always on also. Yes, and I will use some memory. Yeah, example VD400, and this one VD410. Yes, sorry, double integer to real. Okay, no integer, double integer to real, because this one is real also for set point. So VD 400 and VD 410. Yes, and I will copy this one to the manual, right? To here for set point, and for manual set point here, right? So here I will use manual set point VD 520, right? So this one. Yes, paste, and then we will download. Yes, save the project and then download. Find the CPU. Okay, and then download. Yes, start the CPU, and then let's go to status, right? So right now set point 0 and have some PV, because right now I connect with the milliamp. Yes, so it shows some PV. So example, I set point. Yes, go to the set point, the last one, right? Example, I will set point 50 bar. Yes, you see, let's see the PID. Yes, it works. Yes, it will generate the output to the analog output, right? for control some electrical device like drive or some controller. So right now we need to create the HMI screen, right, for show some value or some set point from the HMI. Yes. So first we need to create the, I will outline first. We need to create the feedback, right? It means that PV. So VW0. So let's go to the WinCC flexible and then open our project, the existing project. Here is the existing project. So let's go to text, yeah. And first is the feedback, right? PV or feedback you can write also. Example PV, yes. So PV is the word memory, right? So I will choose word and VW0, right? So that okay. And then one more for manual set point, right? Or we can use the output first. It doesn't matter. So I will create the manual set point first, right? So VD 500 and it double integer. So manual set point. The data is double integer, right? And start from VD 500. Yes. And one more for auto set point, right? So this one is the auto set point. Yes. It double integer also, and then start from percent VD 400. Yes. And one more for output, right? So output is the memory word also. Yes. So here is the word. Actually we can show at the HMI, yeah, for this one. Yes, this one for output. It means that signal from the analog output. Yes. So VW 210. Yes, this one output. The data is word, right? And start from VW 210. So 210, yes, for output. So that's all, right? So we need to create the screen. Yes. Here is the set point, right? So set point, we can go here and then choose the set point, right? Take set point, auto set point, yes. And it is the input, right? And this is a manual set point. So go to manual set point, yes. And this is the input also. So we need to create the screen one more for feedback, right? So this one is the PV, right? And it was output. Yes. And this is a PV, or we can write feedback. Yeah. And one more for show the output status, right? Actually this one is bar, right? If we want to control the pressure, we can choose the bar or kilopascal, yes, etc. And this is output, right? Output percent. And I will move the feedback and set point to be here for easy, right? Yes, like this. And I will align a little bit to be good looking. Yes. Actually we can align like this also. Yes. To be good looking, yes, like this. Yes. Okay, so save our project, and we need to convert the output and feedback, yes, to the percent, right? Because here is the raw data, right? You see here is the raw data for feedback, yes, like this is the raw data. So we need convert this one to the percent, right? So let's go to our HMI and then go here for PV, and then go here, go to property and go to linear scaling. Here is the enable between the value of HMI and value of PLC. So right now our PLC is start from 0 to 27,000 something, yes. So we need convert from this one, yes. PLC is what? Sorry, 27,629. It is the maximum 20 milliamp, yes. And the HMI will show 0 to 100. Okay, example 100 bar something, yes. For this one is 100%. Okay, so one more for feedback, right? Oh, this point, right? Output, right? We need to use this one, yes, output and convert also. 27,629, yes, it will show 100%, yes. And feedback also for PV, yes, we already scale it here. Okay, yeah, save again, and we will download the screen to the HMI, right? So I will download it. Yes. After download, we can write the manual set point or the auto manual control, yes, from the HMI, and let's see the result, yes, after we download. So let's go to here for download the program from the PC to the HMI. So let me choose. Okay, I will let's check the COM port. Okay, I will use COM3 for download. Yeah, so it is correct, COM3, and transfer. Have some compile error, right? Invalid. Oh, manual set point one more, right? For this button, because we not yet create the tag, right? So we need to create the tag also for this one here, M0.0 and M0.1, right? So this is the manual mode. So it is the boolean, right? So M0.0, sorry, M0.1 for manual, and one more for auto mode, right? Auto mode, M0.0, and then go to here and then config for auto mode, right? Auto mode, we can go to the general, go to event, right? So we will choose the invite bit and then go to the tag, right? Auto mode, yes, and we'll reset the bit. When we click here, it will reset this one. Okay, so we will use reset bit and then go to the manual mode, yes, and for manual mode it's the same, yes, invert bit, manual mode, yes, and then reset bit the auto mode. When we press this one, yes, okay, so that's all. And then we need to change some color, yeah, this one is correct, yes. So save our project again and then go to the download, yes, try to download again, yes, confirm to download. Okay, done. So wait a moment for HMI for reboot, yes. Okay, so right now the HMI already reboot, and then let's go to our PLC, yes. So I will select manual and auto mode. Example, manual mode, yes, you see the this one is turned off. Auto mode, yes. Okay, I will show the HMI, yes. Okay, right now I will select manual mode, yes, you see, and this one auto mode, yes, and then I will set point, yes, set point, example, 63 bar, yes, then enter, you see, here, right, and then here is a 63, right, and I will adjust the analog input for analog input, yes, I will adjust, decrease, yes, and let's go to the tool and then check the PID control panel, yes, and let's see here, okay, I will adjust the analog input, yeah, a little bit, yes, and we can tune also, yes, tune the PID, example 0.1, yeah, this one is 25, yes, like this one 0, okay, the output will follow our tuning, yes, and you see the screen will vary the value also, yes, I will adjust the analog input, yes, for PB, okay, I will increase little bit, right now it 64, right, 64 bar, yes, 64 bar, yes, and we can tune the PID a little bit, example 0.5, yes, it's so fast, so we can tune the PID, yes, so if I increase the set point, example 90 bar, yes, 90 bar here from the touch panel, it can go to the, here is a set point, I will adjust the PV a little bit, yes, so the output will not swing so much, yes, because the set point and PV nearly the same, you see, yes, and we can tune a little bit if it so fast, example increase here to 25, yes, like this, you see the PV and SV nearly the same, and the output is stable also, yes, for blue color, yes, So this is a instruction how to create PID control for S7-200 SMART by using Step7 MicroWin SMART version 2.5 and WinCC Flexible version page 5. Okay. So thank you very much for watching my video, and if everyone have any question, please drop comment under my video. I will reply soon. This is for just example, yes. So everyone can do anyway, not different me, yes. Also can use. For this one just example that I would like to show you, yes. So I would like to say thank you very much again, and I would like to request all of you to share, like, and subscribe my channel also to get more notification and more new videos that I will create step by step. Okay. So in this time, I would like to say thank you very much again, and see you next videos. Bye bye. Hello everyone, welcome back my YouTube channel, General Technology Knowledge. Today I would like to show and share about how to connect the PT100 to the PLC S7-200 CPU SR30 and EM-AM03 for analog module. Okay. So before go to create the program, I would like to explain a little bit about how to use this concept. So first, here is the PT100 that we can connect the ohm, yes, value to the transmitter, yes, and then transmitter will provide the output 4 to 20 milliamp, and then we will connect parallel with the multimeter for measure the milliamp, and then connect continue to the analog input module. Okay, and I will provide 220 volt AC to supply the PLC and the temperature transmitter, and I will use software SIMATIC Step7 MicroWin SMART version 2.5 and WinCC Flexible to simulation the screen to show the actual temperature. Okay, so we can also connect directly from the PT100 to the module, but not this module. Other module we can use for analog that follow the manual operation of the module. Okay, so let's go to the software WinCC Flexible and Step7 MicroWin SMART, and I will show and share about how to import and export the library also in this section, because I need to use the existing project that we already learned in the previous video to export the scaling block, analog input and analog output scaling that we already learned in the previous video. Okay, so let's go. So first I will open the existing project for export the library from the existing. Okay, so let me open the scaling. Okay, so first I need to create a new folder, example library. Yes, leave one. Okay, and then I will go to the subroutine. Yes, so first if I would like to export this block, because I'm no need to create this block again. Yes, it means that create this again, so I can export. Yeah, right click here and then use export, and export to where? Okay, export to the list. Yeah, and here we can write another name that we will use, example AIN analog input scale. Okay, so we will got here for analog input scale, and one more for analog scaling, analog output. So we also can export. Yes, here example a analog out scale. Okay, and right now we got two library here, so I will create a new project for this section, and I will use the import. Yes, example import from the folder that we already export to. Yes, here example I would like to export the analog input scaling. Yes, so click here and then click open. Yes, so we will got the analog input scaling. Okay, so we can drag and drop to use, example SM0.0, and then we can drag and drop this one to use. Yes, so example this temperature transmitter rank from 0 to 100%, sorry, 100 degrees Celsius. And the input I will connect to the analog input channel number 1. So AI W0, sorry, AIW 16, right? Because here we need to add the analog input and output expansion module, right? So in the previous video I add the battery, and I will add the EM-AM03 here. Yes, so it will start from AIW16 and AQW16. Okay, and this is a current. Yes, for input, and here is the current for output. Okay, and for CPU setting. Okay, for CPU setting we can start up with run. Yes, so we choose here. Okay, and we can click OK. Yes, and for this one we can use another memory that we want, example MD0. Yes, okay, so we need to download to the PLC, right? So before download to the PLC, first we need to check the LAN cable from our computer to the PLC. Okay. So right now I will connect the LAN cable from PLC to the PC. And then we will set the manual IP address of our computer. Yes, IP4 here. Because the IP of the PLC is IP address of PLC 192.168.2.2. Yeah. So we will set the PC is 192.168.2 something but not 2. Okay. So this is the example .253. Yes, for my PC. And then click OK and OK again and close. And we can ping. Yes. So CMD, or we can go to command prompt. Yeah, here. Type command prompt. Okay. And run as administrator. Yes. And we can ping 192.168.2.2. Yes. So it's so like this. It means that we can connect from our PC to the PLC. Okay. So we can save the project, and this is a new project. So I can type PT100 PLC Smart. Okay. And we can download. And then choose find CPU as. Okay, so right now it detects one CPU that has IP address 192.168.2.2. Okay, and here is the MAC address. And then click OK, and we can download. So during download, it will stop the CPU. Yes, and be careful in this step. If our machine is running, so if we press the download, we will stop the machine. Okay, so in this step we must be careful. So right now I will download and then stop the CPU. Yes, and this download complete, so I can click yes to run the CPU again. Okay, and we can online. Okay, right now the temperature show around 21. Yes. So I need to scale link again. Yes. Let me check the scaling again. Okay, open here. So this one is correct, right? At low scale, yes. The formula is correct. But let me check the milliamp. Yes. Around 7 milliamp, right? Okay, so we need to export and import from other project to use with this scaling. Okay, so I need convert from 0 to 20 milliamp to 4 to 20 milliamp, because right now the PLC is 0 to 20 milliamp and the transmitter is provide 4 to 20 milliamp, so we need to use the scaling. Okay, to export the scaling from other project, example from S7-200, yes, we can go to existing project that I already show in the previous video. Yeah, example, we can use the scaling from here. Yes, S7-200. So we can go to subroutine. Yes, and then export the scale to use. Right click and then export. Yes, here, and save to another folder that we want. Example, I will create a new folder, lift S7-200. Yes, and this is a name that we will create. Example, scaling. Yes, the name is scaling. So we can copy this file to use. Yeah, example, I copy. Yes, and then paste here, and I will paste to the VMware player here in the video. Yeah, okay, and right now we will got the S7-200 lift. Okay, so we can import. Yes, right click and then import, and click yes, and then import from the folder that called S7-200 lift. Okay, here, yes, scaling. Okay, so right now we got the one more block for scaling. Yes, so we can drag and drop to use. So I will use here. Okay, drag and drop this block to use. So we need to convert from scale this one. Yes, so this one is integer, right? So I will convert from integer to real. Yes, because it is the real for scaling, so I will convert from integer to real. Let's see here. Yes, all parameter is real. Yes, so we need to convert from this input to real, right? So I need to convert so integer to double integer, right? Before go to real. So integer to double integer. So this one AIW 16 to double integer, and from double integer to real, right? Di to real here, and here I can create the value, or I can create the temp one, and the data type is double integer, right? So dint Okay, and here I can use temper 1, double integer to real, right? So here I can use temper 2, and the data type is real because we will use here. Okay, so here we can use temper 2, and then I will copy to here because it is the scaling real, and this is a high scale, yes, high scale input, low scale input, high scale output, and low scale output. Okay, so here is high scale, right? So high scale input, it should be 27,648.0, yes, and here it's around 6,382 because I already tested. For output, it should be 22,648.0, and low scale it should be 0.0. Okay, and here is the output for scaling. So we can use the converter before go to page here. So I will use one more for converter. So it is the real, right? So I can use MD example MD0, and I will use function truncate here, and then convert from the MD0 to the double integer right here. So I can choose temper3, it is double integer, or we can use AC0, yeah, it is the internal memory, and then I will convert to integer, right? So double integer to integer, so AC0 to double integer here. Here I can use temp3, it is double integer, it is integer, right? So temp3, and then copy temp3 to here and connect here, and then here should be MD4, right? Because we already use MD0, yes. So we can save the project and then compile, yes, error 0. It means that we can download. So let's download and see the result again after we scale. Okay, right now it's so 21 degrees Celsius, right? So this one around 17. So we need to scale a little bit more. Example, this one should be 5000.0. Yes, and let's download again. In this scale we can adjust. Yeah, if we create the scaling, so we can adjust to be the same as the actual temperature, right? So right now it show around 22 and the actual is around 21, so I can adjust a little bit more. Examples 5200.0, and then we can save and then download to the PLC again. Okay, let's increase a little bit. Download again. Okay, so right now it show around 21 degrees Celsius. Yes, and actual is 21 also. Okay, so right now we need to create the HMI to show this value. Okay, so let's go to the WinCC. Yes, and then I will use the existing project that we already learned in the previous video. Yes, scaling. Yes, and then I will insert one more screen. Yes, add new screen. Example screen 2 for temperature. Yes, so this one main screen, right? So temperature, and then I will create one more text for MD0, MD4 and MDH. We already used, right? So I will revise the PLC to MD. This one should be MD12, MD12 also, and this one should be MD16, right? Okay, so I will download again. Okay, and then I will create one more text. Example PT100. It is the real, right? And MD16. Yes. Temperature sensor. Yes, and here I can change the color to be good looking. Yes, I will use this color, and then I will use the IO file and choose the text. So PT100, right? Okay, and it is the real, so around 100.99, and then I will change the color a little bit. Example, this is the green, and this is a red, and I will change the text increase. Yeah, 22 and center and middle. Yes. Okay, and then I will use the color solid and then use the white color. Yes, and if we would like to use 3D, we can tick 3D. Yes, like this. So I will use the text. Yeah, example actual value of PT100, and I will use the yellow color and then adjust the text size to be 20. Yes, maybe around 18 is okay, or 19. Yes, okay, and the unit, right? I can use like this and copy one more for C. It means that degree Celsius, and then I will adjust this one to be 14, and then use the white color. Okay, like this. So that's all, and then I will, so for default screen here, so I need to call the screen, right? So I will use one more button for call the screen. Example, go to screen temperature. Okay, temperature like this, and I will copy to the screen temperature here. I can write main screen. Yes, or we can write go to main screen. Yes, it's up to you. Go to main screen. Okay, and this one go to event and then click and activate screen. Yes, choose the activate screen and then choose the screen name. So we can choose screen 1. Yeah, it is the main screen here, and for the main screen we can choose the, okay, I will rename the text temperature screen. Okay, okay, I will adjust the font little bit, maybe 9. Yes, okay, like this, and then go to event and then choose click and then choose activate screen. Yes, here, and then choose the screen name for temperature. Okay, So we can save the project and we can simulation. Yes. Okay. Simulation. So the default is screen, the main screen, right? So we don't use this screen because it is the existing video. So we can call screen. Yes. Okay, I will change this one a little bit. It is the output, right? So output. Okay. And then save again and click simulation. Okay. And then I will call the screen temperature screen. Yeah. So right now it show around 21.3 degrees Celsius. Yeah, here the same here. So I will show the actual temperature, and I will test the temperature by using the heater to hit the temperature. Okay. So let me show the screen. So right now it show 21 degrees Celsius. So let me hit the PT100. Yes. Okay. Wait a moment for hitting. Okay. So right now it up to 24 degrees Celsius. Yes, I will hit more. 27. 30. Yes. And the touch screen is show around 32. Yeah. Increasing. 34. I will hit more. 41. Yes. 42. Yes, the same as the touch screen. Here. 46. Yes. And the milliamp is increased also. Yeah. Follow the rank that we already set. Okay. So this is just instruction about how to import and export the library from another project to use without create again. Okay. And show how to create the text of HMI or create the button for call the screen. Yes. So thank you very much for watching my video, and if everyone have any question, please kindly drop comment under my video. I will reply soon. And I would like to say I'm sorry if I have mistake in this video also. And I would like to request all of you to like, share and subscribe my video also to get more notification and more new videos that I will create step by step. So in this time I would like to say thank you very much again and see you next videos. Bye bye. Hello everyone, welcome back to my YouTube channel, General Technology Knowledge. Today I would like to show and share about how to connect the PT100 directly to PLC S7-200 SMART, CPU SR30, and expansion module EMAR02. Okay. In the previous video, I already show and share about how to connect the PT100 or RTD to the PLC S7-200 SMART also, but using the temperature transmitter to convert from ohm to milliamp. Okay, so today I will connect the RTD to the PLC directly. Yes. So if everyone would like to connect directly, first we need to purchase the expansion module model EMAR02 or 04. 02 it means that we can use 2 PC of RTDs, and for 04 we can do 4 RTDs. Okay, and I will use the software SIMATIC MicroWin SMART version 2.5 to configure the CPU setting and the EMAR02 setting. Okay, so here is the drawing wiring that I just draw to easy to understand, and I will show more about how to connect the RTD and power supply to this PLC. Okay, and I will use SIMATIC VinCC flexible to simulation to show the actual temperature of RTD. Okay, so first let's go to see the drawing wiring. So the drawing is very important. If we cannot wiring the connection, we cannot do anything, or it will not show the actual value of the PT100 or RTD. Okay, so first let's go to see the drawing connection. Okay, so here is the drawing detail of this module. So first, here is the CPU SR30. Yes, and here is the expansion module EMAR02, and here is the RTD 2 wires that I already connected to the PLC expansion module EMAR02. So we need to jumping the cable from M plus to I plus, M minus to I minus, and then we'll connect the RTD 2Y to this terminal. Okay, and for channel this channel also the same. M plus connect with I plus, M minus connect with I minus, and then connect the two cable to the RTD 2 wires. Okay, and here is the power supply to PLC 220 volts AC, and here is the 24 voltage that generate from the power supply inside here that energize the power to supply the expansion module EMAR02. Okay, if we not connect this one, this cable 24 voltage DC, so this module is not working. Okay, and here is the address of this module. So it will start from AIW16 for channel number 1 and AIW18 for channel number 2. Okay, so this is a clearly drawing that easy to understand. Yes, about how to wiring this module. Okay, so next step we will go to see the software to configure the CPU setting and expansion module setting. Okay, so let's go. Okay, so here is the software SIMATIC MicroWin SMART version 2.5 that I already installed in my PC. So let's go to open here. Okay, so first go to CPU setting. So here is the model of CPU, yeah, SR30, yes. And the next slot I will create the battery, yes, inside the CPU. And the next step is EM module, right? EM0. So we can go to see the EMAR02 like this. So let's see, here is the 2 AI RTD. If we choose for EMAR04, we can use 4 channels of analog input for connect with the RTD. And we can also choose the AT04. It means that TC thermocouple, we can also connect thermocouple. It means that input is millivolt to the directly to the PLC also. Okay, so in this video I will choose the EMAR02 because to match with my PLC, yes, hardware. Okay, and the address it will start from AIW16 that I already saw in the slide presentation. So we need to setting the CPU. Example startup, I will start the CPU. And for the analog channel, the channel 0, yes, I will choose the thermal resistant 2 volts because right now I use RTD 2 volts. And here is the default, yes, default setting. So we no need to change anything. And for channel number 1, I will choose terminal, yes, thermal resistant 2 volts also, yes, and choose the PT100. Okay, it has many types that we can use. Example, PT200, PT1000, yes, but in this case I will use PT100. Okay, and then choose OK. And to show the actual signal of the temperature from RTD, first let's go to choose the converter. I will convert from integer to double integer, yes. So integer to double integer. It's similar to be S7-300 also for this step. Okay, and I will use AIW16 for channel number 1, and I will convert from double integer to real, yes, double integer to real, and I will convert, yes, divide by 10 because it's the same as S7-300. So divide real. Okay, divide by 10.0. Okay, and for this variable I will choose temporary variable. Example var1. Okay, and the data type should be double integer, yes. Okay, and this one I will choose var1. This one I will copy and paste here, and for this one I will create one more variable called var2, and the data type is real. Yes, because we convert from double integer to real. So I will choose real, and this one should be var2, and I will copy this one to this one, divide by 10.0, and then example md0. Yes. So we need to download this project to the PLC, right? So don't forget, use the always on, otherwise it will error. So SM0.0, and I will create one more channel. Yes, because I already connected the cable from PT100 to channel number 1 and number 2. Okay, so I can copy this one, copy this one, and also copy this one and connect this one to here. Yes, for channel number 2. Then I will change this one to AIW18. Yes, channel number 2. And for this variable, I will change to var3. Data type is double integer. Yes. So this one should be var3. Copy and paste. And this one also var4. The data type is real. This one should be var4, and I will copy and paste here, and then this one should be md4. Yes. Okay, so that's all. Let me compile the project. So error 0. Okay, and then we will download to the PLC, right? So before download to PLC, make sure we connect LAN cable or PPI cable from PC to the PLC. Yeah, but in this case I use LAN cable. Yeah, Ethernet cable. So I will put my computer IP address. Yes, right now the PLC IP address is PLC IP address 192.168.0.2. So I will put the manual IP address of my computer to PC IP address should be 192.168.2 something, but not .2. Okay, so example .253. Okay, so I will put my computer to 192.168.2.253, and the subject mask is 255.255.255.0 because it is class C. And then click OK. Okay. So first let's check the connection by using command from cmd, and then ping 192.168.2.2. Okay, ping to the PLC. Okay, and press enter. So it shows like this. It means that we can communication or connected the communication between our PC to the PLC. Okay, so we can go to download one, and then choose the adapter, yes, of a computer, and then choose the button find CPU as to detect the CPU. It means that detect between computer to the PLC CPU. So in this case, it detect one CPU that has IP address 192.168.2.2. It is here. Okay, so we can click OK to download. Yes, and then we will stop CPU. Okay, and we already run the CPU and we can online. Yes, so let's see here. Channel number 1 show around 25.8 degrees Celsius, and channel number 2 show around 27 degrees Celsius. Okay, so we need to show this actual temperature to the HMI, right? So let's go to HMI. So I will use WinCC Flexible 2000H switch page 5. Yes, and then create the new project. Yeah, create an empty project and then go to panel. I will choose the panel TP177B 6-inch color. Yes, and then I will create the new connection. Yes, the new connection here. Example connection 1. So I will rename this one to PLC SMART. Okay, and then I will choose PLC S7-200. Yes, and then I will choose the Ethernet. So here is the IP address of computer, right? This one. So basically we can type 192.168.2.253, and here is the IP address of PLC. So this one 192.168.2.2. okay, .2.2. okay, and then I will create the text. Yes, so let's go to text. Example RTD1, and it is the real, right? So let's check the address MD0. So this one should be MD0. Okay, and we can command like actual temperature sensor 1, and the next step should be RTD2, and the address is MD4. Yeah, the same here, and actual temperature sensor 2. Okay, and then we will create the screen. So let's change this background to be this color. Yes, and then I will use the text. Example RT sensor 1. Okay, I will change color to be okay, yellow color, and for the text I will adjust to 18, center, and then middle. Yes, okay, and I will choose the IO file to show the actual value of RTD. Okay, so it is the output, right? Okay, and then I will choose 999.9. yes, decimal only 1, and then I will choose take, yes, RTD 0, sorry, RTD 1, and for text I will change a little bit for text around here, yes, and then I will choose center and choose middle also, and for color I will change to green, and for background I will change to black, and for the cover I will cover by white color, yes, like this, and we need to choose the unit also, right? So basically we can copy from here and change to like this, change like this, okay. I will change to like this, okay, degree Celsius, okay, and I can copy, yeah, by select here and then drag and drop, yes, okay, like this. So I will change this one to sensor 2 and change the text to sensor 2 also, yeah, so RTD 2, okay, RTD 2, and then I will choose the text for background, example show the actual temperature from sensor, okay. I will adjust this text size to be 12, like this. It's so small, right? So I will actual temperature from sensor, and I will adjust to be like this and change to ball, like this. I will change a little bit size, yes. Okay, like this. Then I will change the color to be white color, yes. Actually the unit we can also choose the white color, like this, okay. And then we can simulation, yes, okay, simulation to see the actual value of temperature, yes. Okay, right now it show 26 and 27.4, yes, let's see here, okay, the same as the PLC show. So I will hit the RTD to let everyone know, yes, about the actual RTD, yes. So I will hit the channel number 1 first. Okay. Let's see, channel number 1 is increased 47. Okay, 69, yes. and I will hit the channel number 2. Let's see. Okay. And I will show the actual connection that I connect. Yes. And I will explain a little bit about the actual connection. Okay. So here is the cable from the PG100. Yes, here. And then I jump the M plus with I plus, M plus with I plus, and M minus with I minus, and then connect to the RTD. Yes. And here is one more channel. Yes. The same. I jump M plus with I plus, M minus with I minus, and then connect to the RTD two wires. Okay. And here is the power supply, 220 volt AC, and here is the LAN cable that connect to the computer. Yes. Okay. So like this. And I hope everyone will understand about this video about how to connection or how to create the block or CPU setting to show the actual value of the RTD. Okay. So thank you very much for watching my video. And if everyone have any question, please kindly drop comment under my video. I will reply soon. And I would like to say I'm sorry if I have mistake in this video, and I would like to request all of you to like, share and subscribe my video also to get more notification and more new videos that I will create step by step. So in this time I would like to say thank you very much again, and see you in the videos. Bye bye. Hello everyone, welcome back to my channel again, General Technology Knowledge. Today I would like to show and share about how to set up the PID control of temperature controller with PLC S7-200 SMART by using the CPU SR30 and analog output and input module AM03. Okay. And the concept is we need to have the set point and feedback, yes, from the temperature. Example, I set point 50.8 degrees Celsius. So if the feedback around 29 or 48.5, it will increase or decrease the percentage of the control valve for cool the water or something that I already connected from analog output to control the control valve, and feedback from control valve to the analog input for show the percent take off the control valve to the HMI. Okay. And I need to use the temperature controller because I need to convert from PT100 signal that we can call ohm signal to the transmitter and then convert to the milliamp to the analog input. Okay, and I will use software SIMATIC Step7 MicroWin SMART version 2.5, and Win is flexible to simulation this case. Okay, so first we need to create the PID block for control, and the second we need to design the screen for set point and show the feedback of the temperature. Okay, so let's go. So I will use the existing project of PLC that we already learned in the previous video. So let me open. So here is the existing project that we already created the scale of analog input and scale the for convert from 0 to 20 milliamp to 4 to 20 milliamp here, and then we'll generate to the actual of temperature. Okay, so first let me open and download the project to the PLC. Before go to download the project to the PLC, so first connect the LAN cable between our PC to the PLC. Okay, so in the previous video, the IP of PLC is IP address of PLC is 192.168.2.2. Yes, and we need to put the IP address of PC to be 192.168.2 dot something, but not dot 2. Okay, so let me check my IP address. Okay, my IP address is 192.168.2.253, and if everyone not yet put the manual of this IP address, everyone can put follow me. Okay, and then click OK and OK and close, and we can check by use the Control R to run, yeah, or we can write the command prompt, yeah, cmd here, run as administrator, and then we can ping 192.168.2.2 because we need connect to the PLC, right? Okay, so it shows like this. It means that we can communication between our PC to the PLC. Yes, so my IP address of my PC is 253. Yes, so now we can ping. So we can download by using the button here. Okay, and then we can find CPU. Okay, wait a moment for communication. So right now it detects one CPU that has IP address 192.168.2.2. Okay, if everyone would like to configure something, we can configure here to match with our HMI or our another devices that connect with this PLC. Okay, so we can click OK, and we can click button download, and the PLC will stop immediately if we click yes. So right now it already download to the CPU, so we can click yes to run the CPU and click close, and we can online. Okay, so let me show the actual temperature. So temperature right now it show around 23 degrees Celsius. Yes, because I already convert from the raw data to here, convert from 4 to 20 milliamp to 0 to 20 milliamp, and then keep the output here to here. Yes, okay, good. So let me show the actual temperature. It show around 23 also. Okay, right now let's see the temperature. It show around 23 because I already connect the PC100 to the transmitter. Yes, and output is show 0 milliamp right now. So right now we already got the feedback of temperature. Okay, so we can continue to create the PID control. Yes, because we need to have the set point and feedback from the PT100, right? So right now PV we already got it around 23 degrees Celsius. So to create the PID control, first go to tool and then click the PID control here. Click PID. Yes. And then go to tick the loop 0. Totally it has 8 loops that we can use in this CPU. So let me check one for loop 0. Yes. And then click next. Okay. It is the name of the PID. And then click next again. Yes. So here is the gain, sampling time, sample time, integral time, derivative times. Okay. So we follow the default first and then click next. And here is the scaling. Yes. So the maximum of this analog, it show around 27,648 for analog. So it is the low scale and high scale. 0 is low scale, 27,648 is low scale. Okay, and the loop set point is 0 to 100. Yes, example 0 to 100 degrees Celsius. So we can use it like this first, and then click next. And here is the PID type. So it has analog and digital. So right now we use the analog for control. So we choose the analog. For scaling we use unpolarized. Yes, and the rank of this analog is 0 to 27,648 also. Okay, and then click next. And here is the alarm. So default we don't use it, so we can click next. And here is the manual control for PID. Actually we have two modes for PID. The first one is automatic control mode, and the second one we can use the manual mode. Okay, so I will check this box for manual PID control and then click next. And here is the address. It will start from VB0 until VB119. Yes, totally 120 bytes. Okay, and then click next. and click next again, yes, and click generate for finish our wizard. Okay, so right now we will got one more for subroutine. It called PID 0. It means that PID loop 0. So if we would like to use it, we can use by drag and drop this block to the main program, and don't forget use the always on, otherwise it will error, cannot compile the program. So SM 0.0, yes, and here is the PV. So for the PV, it will we can take from here, yes, yes, and here is the set point. So we need to convert from double integer to real, right? Because we need to use the set point. Okay, so I will insert one more for this block for convert. Okay, example, convert double integer to real. Okay, example, VD .500, yes. So I can use the VD 510, yes. Okay, and we can copy here and then paste here. And for the manual and auto mode, I can use M. Example 10.6 or 10.5, yes. And for the manual control, I need to use one more for converter. So I can use double integer to real also. Example VD 600, and this one VD 610, yes. So we can use both for manual and auto mode. And for this one, we can use analog output, right? So the analog output is start from the %AQ W16, yes. So this one should be AQ W16, yes. So if we set point the temperature that we want, so it will generate the output automatically by calculation in this block. Okay, so let me save the project and then compile the project, yes. So it has error, some error, right? Okay, let me compile again. Okay, error 0. So we can download this program to the PLC by press this button, download button, and then click download again, and we need to stop the CPU again. So in this step, we need to be careful, because if the CPU is running and have some machine is running also, so if we push the yes button, it will stop all the machine. Okay, so we need to be careful in this step. So right now I don't have the machine running, so I can stop the CPU, yes. And then the program is already downloaded, and I can press yes to run the CPU again, and then I can online. Yes. Okay, so let's see here. The set point is still 0. Yes. And the PID mode is manual mode. Yes. So if I set point example 50, if I set point 50, yeah, let's see, the analog input is around here. Yes. So I will force this one to 0. Yes. Okay, so if I set point 45 degrees Celsius, and I will put this one for auto mode. Yes. So let's see, the milliamp is start increase. Yes. Yes, start increase by following our PID tuning. So to tuning the PID control, let's go to tool again, and then go to the PID control panel here. Okay. So we can tune the PID. Yes, click here, loop 0. So here we can use the manual tuning. Yes. So before the manual tuning, I would like to create the HMI first. Easy to set point. Yes, from the HMI. Yes. So actually this one we take from the milliamp from analog output to control the control valve, right? To control the control valve here. Yes. So let's go to create the HMI project. Yes. By switching the VCC flexible to sound edge. Yes. Okay, and I will choose the existing project, or we can create the new project. Okay. So the better way is create the new project. Yes. So choose the create an empty project, and I will use the panel example here, TP177B6 color PN/DP. Okay, wait a moment for opening the project. Yes. So first let's go to the connection. I will create a new connection. Yes. Example new HMI. And I will connect to the S7-200 SMART, right? So we can use here. And for the connection, I will use Ethernet. And here is the IP address of my computer. So 192.168.2.253. Yes. 192.168.2.253. And here is the IP address of PLC. So 192.168.2.2. Okay. So we need to create the text, right? So go to the text, and for text number 1, we need to create the text for show the actual of temperature, right? So MD16. So let's go to PT100 PV. Yes, and it is the real, and start from VD16. Yes, so this one we can comment. Yeah, process variable of PT100. Yes, sorry, MD, right? MD 16. So it will start from MD16. Yes, and the second one we need to create the set point. Yes, for PID, right here. So VD 500. So PID set point, it is double integer, right? So VD 500. Okay, so we can mention the command PID set point, and the next we can insert the button for select the manual auto, right here. Okay, here. So M10.5, it is the boolean, right? So PID mode. Okay, and it is the boolean. So M 10.5. So PID mode. Okay, and we need to show the actual to control the control valve, right? Okay, so I need to convert from this one. Yes, to show on the HMI, right? Okay, so I need to show the analog output to the HMI also, right? To set point of the control valve. Okay, so let me outline first that I need to modify this block. So basically we can use move word. Yes, and I need to use this one to here, copy, and here I can use VW 300. Yes, or we can use another address that we want. Yes, so the first one I need to show this one to the HMI, right? So we can go to create the new text. So output control valve, and it is the word, right? So VW 300. So this is the output for control the valve. Okay, so right now we already created the text. Yes, then we can go to the screen to create the new IO file. The first one is set point, right? So here we can go to the, okay, like this, and it is the input, right, for set point, and for the text is here set point. So I can go to property and then change this one to be green, and change the field to be red, sorry, black, and this one should be use the white, and we need to align to be center and middle, and I need to use the Takuma ball example of 14. Yes, yes, so this is a SV, or we can call a set point. So I need to use the label. Yes, set point. And I will change the color of screen to be this color. Yes, and then I will use the color of the text to be yellow color, or actually we can use white color. Yes, and then I will change to the 16. Yes, so we can copy, yes, by pressing the Control and Shift and then drag and drop. So example feedback. Okay, so this one should be output. Go to the general and tick this one output because it is feedback, and this one should be output. Yes, PB, and then we can put the unit. Yeah, example this one, and then we can copy. Property, I can change the font to be 12 and change the color to be yellow. It is the unit, right? I will adjust this one to be 18. Then we can copy to here. Okay, and then we need to show the output to control the control valve, right? So we can copy from here. Yes, okay, and this one should be output or analog output. Yes, output. And the unit is percent because the control valve is got 0 to 100% for input, and output feedback around 0 to 100% also. Okay. So I will use the rectangle, yes, to be like this, and then send to back. Yes. And then I will change color to be like this. Actually we use a white color, so I will change to white color. Okay. And then I will put on the center. Yes. So here I can adjust a little bit, and then put the title of this PID. Example, PID of temperature sensor. And I will decrease the font size a little bit to be 10 or 11. Okay. And here I can change to be this color, or we can use white color. Yes, easy to look. Okay. For font, maybe I will adjust a little bit. Yes. Okay, to be like this. So I can put here. So we can use the simulation. Yes, click here to simulation. But before simulation, I need to check the text. Yeah. Okay, this one for output, right? So output, we need to use the output. Okay, here. And then I will convert. Go to property and then go to linear scaling and then tick here. So PLC is 27,648, and it will show 0 to 100%. Okay. So it is very important that we can convert from the actual raw data to percentage to show on the HMI. Okay. And the last one, we need to use the push button, right? To select the PID mode. So I can use the button. Yes. So this one we can use auto mode. Yes, we can select this one and then it will use the auto mode. Okay. So go to event and then go to the press or click, yes, and can use the invert bit, yes. So I will invert bit, okay, choose the text, this one, PID mode. When it on, it should be show the auto mode also. Okay, and then we can simulation again. Okay, so right now it show around 23 degrees Celsius. Yes. So let me online. Okay, let's download again because we already revised the program. Okay, online. So let's check here. If I press it mode, manual mode, right? I press again. Let's see here on, and then use the auto mode. Okay. So when off, it will show the manual mode, right? So let me change a little bit. So this one should be manual mode. Okay, simulation again. Okay, let me adjust a little bit. Okay, so right now the temperature is show around 23 degrees Celsius. So if I set point 50 degrees Celsius, yeah, here, let's see here, and then press the auto mode. Let's see the output is start adjust, yes. So right now around 27% to control the control valve, yes. So we need to change the manual mode or auto mode when it's on, right? So I will choose the auto mode for all. When we press is auto mode. Okay, and then we can change the screen and then simulation again. I will set point 60 degrees Celsius, yeah. And the output is start adjust, right? Because the process variable is less than set point, right? So in this step we can tune the PID. So let's go to tool and then go to the PID control panel and then go to loop 0. Yes, here for the screen. And then we can manual for tune the PID. Example, I use the 1.5 for gain. So I need to update the CPU. Yes. So the PID will faster than before. Let's see here. It will start increase. Right now the percentage is start increase. Yes, let me show the milliamp. Yes, so right now it show around 19.99 or 20 milliamp. Yes, because our target is not yet go to 60 degrees Celsius. So let me hit the temperature sensor and then let you see the result. Yes. So I will hit the temperature sensor. Because right now the actual temperature around 22 or 23 degrees Celsius. Okay, it start increase. Yes, because I hit the temperature sensor, or we can call PT100. Okay, let's see, the output is swing. Yes, so we can tune the PID. Yes, that's why we need to tune this control panel. Yes, otherwise we cannot control the control one because the output is swing a lot. So let me hit a little bit to be hotter than this one. Right now temperature around 44, 45 degrees Celsius, and the output is swing. Yes, so let me adjust the PID tuning, yes, to be stabler than this. Okay, let's see, the output is swing so much. Yes, so we need to adjust the gain, right? So integrate this one around 0.1. Yes, let me update the CPU to be stable. Yes, let's see if we adjust the gain to smaller than this one. Let's see, the output is stable. Yes, okay, stable around 83 something. So I will hit more temperature. Yes, okay, I will show the milliamp. Okay, right now around 16 milliamp. So let me hit the PT100 to be greater than set point, right? So what happened if we hit greater than set point? Okay, so the milliamp is start decrease. Yeah, because the set point is less than process variable, right? So the milliamp start decrease. Let's see. So the damper or actuator will decrease also. Okay, so if I decrease the set point, example decrease to 40 degrees Celsius. Yes, let's see, it will decrease. Yeah, but it's so slow, so we can adjust the gain a little bit. Example 0.5. Okay, so let's see, it will decrease, and we can adjust the integrate time. Example, it is minute, right? So we can use the 0.6 minute. Let's see what happened. Let's see, the output is swing also, followed by this one. So we need to use the PID tuning to tune the process to be stable, yes, but we need to adjust by following the trend operation here. So right now it's swing, then we can adjust. Example 0.8 minutes. Okay, it will stable, yes. So if we would like to process stabler than this, we need time to adjust or tuning the PID, yes, by using the gain, integrate, and deviate tune time for adjust. Okay, so this is just example about how to set up the PID wizard of PLC S7-200 SMART by using the analog input and output. Okay, so thank you very much for watching my video, and if everyone have any question, please kindly drop comment under my video. I will reply soon, and I'm also sorry if I have mistake in this video, and I would like to request all of you to like, share, and subscribe my video also to get more notification and more new videos that I will create step by step. So in this time, I would like to say thank you very much again, and see you next videos. Bye bye.